Yeah.
Yes, sir.
So, Professor Praveen sir, shall we start with the session if you could permit?
No problem. I'm okay. I'm all right.
Yeah. So, good morning, friends, once again. As it is the second week and very first day of this second week of this refresher course, we're going to start with the help of one of our renowned and scholarly expert in this field of chemical sciences, Professor Praveen Upre sir. So, first of all, I extend my warm welcome to Professor Praveen Upre sir, our distinguished course coordinator, Professor Manisha Kolape madam, and all our learned participants, those who have gathered from across country from the different higher education institute to this refresher course. And first of all, may I request Dr. Meenakshi ma'am to please introduce our guest in brief, and then we'll start with this session. Dr. Meenakshi ji, please.
Okay, sir. Good morning, everyone. I am Dr. Meenakshi, working as an assistant professor at Guru Gorakhnath Ji Government College, Hisar, Haryana. It is my absolute privilege to welcome you all to today's session. We are gathered here for the UGC-sponsored refresher course in chemistry, proudly organized by the Malviya Mission Teacher Training Center at Sant Gadge Baba Amravati University. On behalf of the organizing committee, all the uh, distinguished participants, and on my own behalf, I extend a very warm and cordial welcome to our eminent resource person joining us today. It is now my distinct honor to introduce our esteemed guest, Dr. Praveen Opere. Dr. Praveen Opere is a principal investigator leading the 10x Technology and Biotechnology team at the Activone R&D Center in South Korea. With over 17 years of rich research experience, he is a highly accomplished scientist who specializes in biomass conversion processes, catalysis, chemical engineering, and cosmetic formulation. His prolific contributions include more than 45 published research papers, 6 book chapters, and an impressive portfolio of over 73 patents. His outstanding work has earned him prestigious accolades, including the Brain Pool Scientist Award, the City Mayor Award, and the Best Researcher Award 4 times. Today, Dr. Upre will be sharing his deep expertise on a very crucial topic titled Catalysis for Sustainable Chemical Processes from Biomass Conversion to Green Chemical Manufacturing. With utmost respect and on behalf of everyone present here, I invite Dr. Praveen Upre sir to take over the session. The virtual platform is yours, sir. Welcome. Over to you, sir.
Yeah. Okay. So may I share my screen first? Uh, is it visible?
No, sir. No, no, no.
No. Just a minute. Okay. Okay. Is it okay?
No, sir. It is not visible itself.
Uh, uh, wait. Okay. Now maybe it will be all right, right? Is it okay?
No, sir, it is not visible.
Sir,
Huh?
screen. No, sir, no. Still, it is not visible.
Okay.
Yes,
Yes,
sir.
now
Now
Yes,
it
sir.
is visible,
Yes,
sir.
sir.
Visible.
now it is visible, sir.
Visible. Okay. 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 Thank you. First of all, I would like to say thank you, Dr. Kodape, madam, for nice invitation. And also, I would like to thank you, all committee member, and Dr. Meenakshi for my introduction. I'm very happy to be here and present my research work. Actually, I'm not an academic person, I'm an industry person. And uh, today's talk is related to catalysis for sustainable chemical processes and chemical conversion of biomass into chemicals. So these are the contents of my today's talk. Introduction. I would like to discuss about my institute, my company, and my refinery, my research background, and my developed chemical processes. And in brief, I would like to discuss hybrid bioethanol process, which developed by myself with my major contribution, and also integrated process for the bio-based pentanediol. And then I will conclude. So the CRICT is the Korea Research Institute of Chemical Technology. It is very famous research institute in Korea for chemical and chemical related field, and it is already in one of the top 10 100 research institute global as a global innovator by Thomas Recher. And in Korea, it has like a three main headquarter. One is in Daejeon. It is exactly center of Daejeon. Daejeon is very beautiful city of Korea. It is known as a Yongwon city. Yongwon means researcher city. Same as in India, we Pune is considered as a research city. So same Daejeon is in Korea. So one of the headquarters located in Seoul, and another is in Ulsan and Yeosu. At present, I'm working in Activon. Activon is a cosmetic industry. What we do, we usually produce the bio-based ingredient. Bio-based ingredients means biomass derived chemical using some fermentation or catalytic technology, which are useful for the cosmetic. As you know, if the chemical or some ingredient derived from the petroleum, it cannot be used for the cosmetic, or it can be considered as a very lower grade cosmetic because it harm the skin. So in that case, synthesis of bio-based chemical means the chemical should be derived from the biomass, can be utilized in the cosmetic. So we are like a multifunctional raw material supplier, develop sustainable, effective ingredient-based green biotechnology, eco-friendly competent cosmetic ingredient supplier. We are well known for some diols and kind of a bio-waste and the cosmeceutical. We are well known as the cosmeceutical industry. At present, plastic waste, CO2, and biomass to value-added chemicals like a booming topics, and in most of the research research institution as well as industry, more is like a very booming area. Most of the researchers are focusing on conversion of bio-waste, CO2, and biomass into chemical. As you know, the fossil resources are the maturity stage, and our energy needs mainly depend on the fossil resources. So, in order to prevent the sustainability, we can utilize the waste and renewable resources, which can reduce the dependence on fossil feedstock, which can also allow us to save our environment, climate impact, resource efficiency, some circular economy, energy security, and economic value. The main important uh, main important research, main important ongoing research is plastic waste, CO2, biomass into chemicals. As you know, the plastic, CO2, and biomass. Biomass, I will explain in upcoming slide what is biomass, and most of you know what is biomass. Are abundant on the earth, and these are the sustainable carbon source, which advanced catalysis and some technologies. This feedstock can be transferred into wide range of valuable chemicals and material, which enabling low carbon and circular future. Most of you are aware of biorefinery and biomass, but I believe that some audience are the students, so I would like to introduce what is biomass and what is biorefinery. Biorefinery is bio-based production system. As you know, the biomass is referred to the any kind of waste, whatever the waste, it's a food waste, it's agriculture waste, animal waste, whatever the waste, we consider it as a biomass. So biorefinery is the bio-based production system which can integrate biomass processes and equipment to produce fuel, power, and value-added chemicals. These are the schematic representation of biomass feedstock. So biorefinery can produce bio-based chemicals and biofuel, which are useful for our society. What energy consumption profile I have taken from this source. Here you can clearly see our deficiency, and the disposal resources are almost at the maturity stage, and they are moving toward their declination. And another issue caused by the use of these fossil resources are global warming, some pollution issue, and their disposal, their storage, and their transportation. So in that case, we need to find some alternative source of carbon which can fulfill our energy demand. So in that case, we consider biomass, and biomass is a biorenewable resource which can be utilized for the several years without any declination. So integrated biorefinery of biomass can produce biomaterial, platform chemical, biofuel, and bioenergy. My research mainly focus on the synthesis of platform chemicals, and biofuel. As you know, their cost means the chemical which derived from the biomass are most expensive because the process are like a very costly, but they having huge demand for various application. As you know, nowadays healthcare industry, cosmeceutical, pharmaceutical industry, we want some medicine or some food or any cosmetic product should be derived from the organic carbon. It should be natural, 100% natural. So it is very expensive and it is having high demand. So in order to make them affordable, the basic research is necessary, and I'm working on it. And similarly, there are many researchers working on it. So in order to convert this biomass into useful platform chemical and some chemicals, biofuels, bioenergy, there are some tools such as hydrolysis, dehydrogenation, isomerization, hydrogenolysis, condensation, oxidation, etc. My research area, I mainly focus on the hydrogenation of biomass feedstock into evaluated chemicals, and also I explore other reactions too. So from this slide, you can understand what is my research background, what exactly me and my research group doing for the industry from biomass to chemical. So biomass contains cellulose, which is polymer of hexose sugar, hemicellulose, which is a polymer of pentose sugar, triglyceride. This is triglyceride. It is the side product of biodiesel and our edible oil, and also one feedstock is the lignin, which having phenol-like structure. So while fermentation and hydrolysis and pre-treatment of this initial bio-based feedstock can produce exhaust sugar and pentose sugar, and further treatment of this initial feedstock can produce platform chemical and validated chemical, which are useful for our human society as well as industry and wherever it is necessary. Uh, I would like to briefly introduce active-on refinery means mm, what exactly my team and my research group is doing. Active-on refinery, we are producing multifunctional ingredient. Actually, these are coating. These are some diols and EHG type of material, some preservative, actives, and others. These are the ingredient for the cosmetic. So my research area means my role in this industry is I used to develop catalyst-based technology, catalysis processes in which I design and develop catalysis as well as fermentation process. Also, I design some chemical conversion, some reactor design from laboratory scale to commercial scale, hydrogenation, hydrogenolysis, dehydration, etc. And at current stage, my target is to produce diol from biomass and their purification for the value for the cosmetic and healthcare industry. Here, biomass means any kind of biomass which should be cheaply and easily available by refinery of biomass using catalysis and produce green product. So throughout my research career, these are the main processes which I developed with my major contribution: lactide production from lactic acid and alkyl lactate, and conversion of hexose sugars to dihydroxymethyl porpyrrol and its derivative, and conversion of pentose sugar to porpyrrol and its derivative, and conversion of hexose sugar to linoleic acid and derivative. In upcoming slide, I will briefly explain this technology. And these are the list of developed process which I developed lab scale, and most of them already developed to pilot scale, and few of them already reached to the commercial scale. So uh, uh, as you know, what is meant by homogeneous and heterogeneous catalyst. Actually, I believe that most of the audience are students, so that's why I prepare this type of basic slide. Homogeneous catalyst means it's a visible catalyst. Catalyst and reactor are in same place, and in case of heterogeneous catalyst and reactor are in different place. Advantage of homogeneous catalyst is highly active, excellent selectivity, but in most of the cases, selectivity depends on the active sites. In case of homogeneous, it is having uniform active site and mild reaction condition, but there are some limitations such as the difficult for the separation and at least recovery and reusability. So it has industrially it has a lot of limitation. But in case of heterogeneous catalyst, easy separation, recycling, high stability, suitable for continuous processing and industrial scalability. Uh, it is also having the limitations such as low selectivity in most of the cases and mass transfer limitation. But if we design like a proper and suitable catalyst, so it can work same as the homogeneous catalyst. These are some types of heterogeneous catalysts such as metal catalyst, supported metal oxide, acid beta, and mixed oxide catalyst. So how catalysts work? How catalysts work? A catalyst increase the rate of chemical reaction by providing alternate pathway with low activation energy, and it should not be consumed. It should be reusable next time. So in this schematic representation, you can clearly see how clearly see means I explain this. When we treat some reactant and heterogeneous catalyst, it is not miscible. But when the treat and reach to some optimum conditions such as temperature, pressure, or whatever the optimum condition, the reactant diffuse on the catalyst surface. First, it diffuse and form the bond with the functional group or some surface active site and produce the product, whatever the desired product, whatever the active site, whatever the selective site, it can produce some desired product. And most important thing step is the diffusion. Diffusion means the adsorption and desorption. The adsorption and diffusion are most important in case of heterogeneous catalyst. So adsorption of reactant and diffusion of product. So once its product is formed, it should be immediately diffused out. So it can again go for the next round. Adsorption, reaction, product formation, desorption, and catalyst regeneration. And we can easily recover the catalyst by simple filtration or some regeneration step. So this is the schematic representation where I can say how the catalyst work and how we can regenerate it and how it can be utilized for the next reaction. So my research background, throughout my research career, I developed several heterogeneous catalysis process for biomass conversion into value-added chemicals from cellulose and hemicellulose. As I already explained, cellulose is the polymer of hexose sugar, and hemicellulose is polymer of pentose sugar. The treatment of cellulose, fermentation or catalytic hydrolysis treatment of cellulose can produce hexose sugar, and further its hydrolytic treatment can produce HMF, hydroxymethylpurpurol. HMF is a hydroxymethylpurpurol. I will explain in brief in next slide. So HMF is like a very useful platform chemical. It can easily convert it into DMF, dimethylpurpurol. It is considered as a fuel. Dihydroxymethylpurpurol, it is the monomer for the polymer. FDCA, you all aware of FDCA, it is also monomer for the polymer. And in case of like a carboxylic acid, leucinic acid, lactic acid, alkyl lactate, butyl lactate, it can also produce some platform value-added chemical which are useful in food and flavor industry. Fuel, lactate is monomer for the PLA, alkyl acid also monomer for the polylactic acid, and biobutanol considered as a fuel. And in case of hemicellulose can produce PDO. PDO is like a very useful ingredient in cosmetic industry. It is, as you know, my industry, it's like one of the leading industry in the world, which is supplying this pentanediol for all the cosmetic industry. It is it is good for the skin as well as for the preservative. So when we start the when we start any new process or reaction, we usually check the problems in existing processes and objective. Most importantly, we check it is economically viable or not. Along with this, we check other problems such as in case of homogeneous catalyst, it usually observes serious catalyst deactivation in liquid phase. As you know, the both phases are same, homogeneous catalyst and reactants. So catalyst deactivation, and we cannot reuse this catalyst next time. And in most of the cases, challenges in selective synthesis of biomass-based chemicals and value-added chemical. As you know, biomass is contain multifunctional. It's composed of multifunctional compound, And when we deal with any homogeneous catalyst, there is no selectivity. We can produce like several products, and then it affect the cost of separation. And then this is in most of the cases necessity of high pressure condition, leaching and sintering of active metal component because it is miscible. And in most of the cases, like industrial expert and researcher recommend use the carboxylic acid instead of carboxylic acid directly. It also like increase one step, make the ester and use for the hydrogenation and produce the product like that. So it is also like a cost effective, and in most of the cases active sites are like unidentified. So in order to develop any process, active site must be known. So like we can develop this catalyst very easily for lab scale to manufacturing scale. And in most of the cases, we could not found the long-term hydrogenation of aliphatic acid into desired product. And in case of homogeneous catalysts, there are like well-known issues such as separation, residuability, corrosionase, safety concerns, and the char formation. So to overcome this issue, we like develop our aim to develop a stable heterogeneous catalyst and efficient process for chemical synthesis and conversion of bio-based platform chemical into value-added chemical with high yield. So here I would like to introduce my process. Actually, in this presentation, I have taken like 4-5 processes. So I briefly introduce few processes, and in detail, I will introduce 2 processes. So this is the research project 1, integrated process from glucose to HMF and its derivative. HMF is hydroxymethyl perfenol. It contains aldehyde group and hydroxyl group, and because of this group, this compound is very useful and already is one of the top 12 platform chemical by US Department of Energy. This hydroxymethyl can be easily converted into dihydroxymethylfuran hydroxymethylfuran and dimethylfuran. And this can be produced from the dehydration of fructose. Also from glucose it is possible, but as you know, the glucose have very stable ring structure. To break this ring and produce this chemical, it produce lot of oligomers, and which are not useful. So this route is always like a recommended route. So insulin contain fructose monomer, and cellulose contain glucose monomers. So hydrolysis of this initial bio-based feedstock can produce this C6 sugar. Glucose can again isomerize into fructose, and the dehydration of this fructose can produce hydroxymethyl perfenol, and then value-added products such as DHMF and DMF. So here you can see the step-by-step integrated process. In step 1, glucose isomerization into fructose. Actually, in industrial scale and in industry, like the fructose extract out from the sugar residue. Also, in some industry working on the glucose isomerization into fructose. In most of the study and the process, the fructose yield was very low, and it takes long reaction time. And in most of the cases, humin formation. Humin means the oligomer, unwanted oligomer, which cannot be reused. It is just a waste. So we should reduce this humin formation when we deal with this reaction to produce HMF or fructose or any other products. When we are like consider sugar or biomass as a initial feedstock, so humin is the side products. Like we have to consider that. So what we can do, we can only minimize this product. We cannot omit this. So in most of the cases, in case of heterogeneous catalysis reusability is very important, and once it form, the sugar separation is most important. You know why the sugar separation is important? When we produce fructose from glucose, there is some equilibrium level. It's mostly we can produce maximum 55% of fructose from glucose. We cannot break this. We can break this, but it needs some different techniques. So in our process, we able to produce around 50% yield for the fructose with high purity, and reaction time was very short. And we utilize the catalyst for 5 times, and also we develop a process for the sugar separation. We can easily separate glucose and fructose from this mixture. And once we produce the fructose, we convert it into HMF, hydroxymethyl perfidol. As I said before, HMF is very reactive, but it is also very unstable. If you keep it outside at room temperature, it starts its degradation because of this highly reactive aldehyde group. So in industry, HMF separation from the crude is like a very cost consuming process. So because of that, cost of HMF is very high. But if we can uh, utilize it how it produce, so it is good. So it takes longer reaction time, hemine formation, catalysis visibility, HMF utilization. These are the major concerns when we produce HMF from the fructose. In our process, like we develop one very good process, we obtain very high yield for the HMF. We use, in this case, we use butanol as a solvent. We produce this HMF in butanol. That's why it is very stable, and we can maintain it as it is. It did not degrade. The purity was 99%, and we convert it into in within very short reaction time, within 2 hours, 2 to 3 hours, and we tested reusability for several times. Also, we utilize this HMF and butanol crude for the production of DMF and DHMF. As you know, the butanol can also consider as a next generation biofuel because it is having the very good fuel properties as gasoline. So when we produce this mixture, so we can use DMF and butanol mixture as a biofuel. And in this reaction, we obtain very low hemine formation. This is also the main advantage of this process. So throughout this process, we able to produce DHMF, which is the monomer for polymer, and DMF, which can be used as a biofuel. So we successfully demonstrate this process up to pilot scale level. Another important project I handle with my major contribution, direct lactate production from lactic acid. There are like a few processes which are already commercialized from these industries, Naturework, Puroc, Musa, Shino, Unde, and Ferro, and these are the two-step process. Lactic acid converted to oligomer, and then breaking up this oligomer into lactate. Lactate. Most of us know what is meant by lactate. Lactide is the monomer for the PLA. At current scenario, we must produce the biodegradable plastic because you know the degradation or the in case of pollution and the recycling issue, uh, there are like a lot of plastic on the earth, and we cannot decompose it very easily. So in that case, if we produce the biodegradable plastic, it is good for us. So we can use it, we can degrade it, and it can save our earth. So lactate is most important monomer to produce biodegradable plastic. And as you know, our lifestyle, our life, and our daily life mostly depend on the plastic. From our mobile to our car to aeroplane, we need a plastic. So this is most important compound. So these are the exercise process. So, but when we start from the lactic acid, it can produce only 50% of around 50 to 60% of lactate of theoretical yield, and most of the lactic acid goes into oligomer, and which we cannot use. It is just waste. So to overcome the disadvantage of this two process, we develop one-step continuous process. This is two-step process, one-step continuous process, and this two-step process operated under vacuum. Optical selectivity was low. They use homogeneous catalyst, means separation issue also there, and heavy oligomer waste. in quick process, one-step continuous process, we operated it under atmospheric pressure without any pressure, high yield of lactate, high optical purity, heterogeneous catalyst which can be scalable, and long-term stability. We tested this catalyst more than 3,000 hours and without any waste. So this is the beauty of this catalyst, and we already tested this catalyst up to pilot scale. And maybe most of you aware of Lotte Chemicals and LG Chemicals. They are like interested in this technology. So we are doing investigation. There are ongoing investigation in this industry as well as in CRIT. It's going on. Another important platform chemical is liolinic acid. Liolinic acid already approved in top 10 validated platform chemical by US Department of Energy due to its biodegradable, non-corrosive, non-carcinogenic, and it is easily soluble in H2O. Because of these properties, also it is having like a starting reactant for the most of the valuable product, such as Angelica lactone. It is used as a solvent and intermediate in cosmetic, also in pharmaceutical industry. 1,4-pentane-diol, it can be used in the polymer industry. In case of GBL, it is having high demand in food and flavor industry because of its smell, sweet and pleasant smell. And it can also use as a feedstock and intermediate for several compounds. And in case of ethyl linolenate, it can be used as a solvent for biodiesel. NMP can be used as a solvent and intermediate. And in case of MTHF, methyl tetrahydropiron, it is considered as a P series fuel alternative to gasoline and green solvent. But in that case, we need to change the engine. So at present, we have like gasoline and diesel. So if necessary, like we can use this MTHF and DMF as a fuel. So in this project, what we did for exhaust sugar to chemicals. What we did, we treat cellulose and C6 sugar into liolinic acid using sulfonated graphene oxide catalyst. Actually, this catalyst is, if you use the graphene oxide, it is expensive, but if you use the graphitic carbon or some graphite, it is cheap. And also, if you use the carbon, it is also cheaper than this catalyst. But this is for study we did. So in this case, we develop a process using carbon as well as sulfonated graphene oxide catalyst from cellulose and C6 sugar into liolinic acid. It produces liolinic acid with high yield, with high purity, short reaction time, and also allow the catalyst usability more than 5 times. And this yield is better than the well-known biorefined process. The biorefined process is already existed, and this is our new process. In this process, formic acid co-produced with the liolinic acid via hydrogenation of liolinic acid without hydrogen and with hydrogen. Able to produce the GBL, gamma valurolactone, and methyl tetrahydropiron. In both the cases, the catalyst we design and develop based on the transition metal catalyst, and we tested this reaction in more than 300 hours, and it is having potential for the industry. So another integrated process, pentane-diol from xylene. Xylene is it's composed of pentane sugar, xylose sugar. The treatment hydrolysis of xylene can produce porphyral and porphyral alcohol, and further hydrogenation of porphyral and porphyral alcohol can produce pentane-diol. This pentane-diol is very useful in cosmetic industries. Actinol 5UN means it is the code for 1,2-pentane-diol in our industry. It is 100% natural bio-based carbon, color-free, odor-free, soluble in water, organic solvent, non-corrosive, non-carcinogenic, suitable for the sensitive skin, provide light and elegant skin feel, suitable for all type of skin and oral care. And there are like a lot of advantage using this bio-based pentane-diol. If you use the petroleum-derived pentane-diol, it has lot of limitation. It's not accepted in like most of the high brand cosmetic industry. So the In this process, we have some key points such as the this is 100% bio-based carbon process from biomass to chemical. Continuous catalytic process for the patent dial. This is continuous. Continuous process means there are like two types of process. One is the batch type reaction. So you can take several batches, open it and filter it and use it. But in case of continuous, once you load the catalyst, you can pass the feed and collect the product for the longer time. And this is the continuous process. In batch type, you can start for a particular time and check this several reactions. This is batch type process. The continuous process having several advantages over batch type processes. Industry. In industry point of view, the continuous process is recommended process than batch type processes. So in this process, we develop a stable alloy-based heterogeneous catalyst which offer long-term stability and offer regeneration efficiency. Using this catalyst, we achieve 100% conversion, high yield for pentane diode, low oligomeric waste, extremely favorable and efficient for purification. And this technology is already commercialized. Actually, in China, there are like two industries. One is Jedison and another is They have like I can say maybe if you are aware of Amravati University, so that industry almost covered that area, and they store half of that area for the corn store. In actually, that industry is located in Puyang province something. Uh, their farmer, like they produce the corn, they take out the like a corn cod and they donate the corn store to that industry, and they produce chemicals from that corn store. So it's really like a good. They set a very good example from corn store to chemical. Using this technology, they are like using our technology and providing product for us. I mean, product for active one. So another project I would like to explain is hybrid biobutanol process from biomass. As you know, butanol is superior and next generation biofuel and bio-based chemical than ethanol. There is one existed process, petrochemical process, is known as AGZA process. Naphtha cracking petroleum residue and naphtha cracking of this petroleum residue at very high temperature can produce propylene. Propylene means not selectively propylene. It can produce several alkane and alkyne, and then need to separate out the propylene, and further the treatment with syngas and CO2 can produce butyraldehyde. And further hydrogenation of butyraldehyde can produce butanol and side product. So it is having it is multi-step process, and it is having some very limitations. To overcome this limitation, we also design one process. We just label it as a hybrid biobutanol process. So biorefinery process from CRICT. In this case, we produce biobutanol from biomass. In this case, we use woody biomass and use the bacteria. Clostridium tributylicium, I can read this name. The fermentation of this woody biomass can produce butyric acid, and further hydrogenation of this butyric acid can produce biobutanol with very high yield. And this process having several advantages over this existed petrochemical process. So here I would like to briefly explain this process. Briefly explain this process. For this conversion, we develop ruthenium tin zinc oxide catalyst. This is nano-alloy catalyst for continuous production of biobutanol from biobutyric acid. But as I discussed, biobutanol can be considered as a next generation fuel because it is having a high energy density than ethanol, and which is this energy density is same as the gasoline. It is less corrosive, it is having less polarity, less volatile. It is most important, it is immiscible in water. As you know, in rainy season, if if the petrol or any fuel mixed with the water, then our vehicle cannot start. So in this case, it is miscible in water. So, but in this case, we need to like modify some engine and also compatibility with existing infrastructures. This is experts. Most of the experts saying bioethanol is superior than bioethanol, but the production cost at this moment is slightly expensive than bioethanol. Here also, before starting this development, we also point out some problems in existing processes and set our objective. The problems are like the same as I discussed before. So to overcome this problem, we set our objective to develop stable heterogeneous catalyst and continuous process for the chemical conversion of butyric acid into butanol with very high yield. So from literature, from literature study, we come to know that it need some metal supported catalyst, because this is hydrogenation reaction. But as you know, ruthenium is very active, and if we use the transition metal catalyst, it has some a leaching problem, because in this case we are going to use butyric acid as it is without any solvent. So first we design this catalyst ruthenium tin alloy on zinc oxide catalyst and design the procedure. This catalyst synthesized by co-precipitation method. Co-precipitation method means the simultaneous precipitation of precursors using base. So using this method, we synthesize the catalyst ruthenium tin, ruthenium 3SN7 alloy on zinc oxide, and when we precipitate dry and calcine, it is metal oxide or hydroxide form. So in order to make into applicable for the hydrogenation or oxidation reaction, so we need to reduce it. So we reduce it at 420 degrees Celsius under hydrogen. So after this pre-treatment, it is very important that the alloy phase or any metallic phase produce or not. So XRD is the best technique to know the crystallite and phases present in the catalyst. So this is as synthesized. As synthesized means dried catalyst, and this is reduced catalyst. And this is the JCPDS pattern from XRD instrument. Actually, XRD have some database where we can check the JCPDS pattern for the each component, for metallic, metal, alloy, oxide, hydroxide, etc. So here you can clearly see the alloy phases. Ruthenium 3 and SN7 alloy phases clearly match with this pattern. It means the alloy phases are produced. S2TPR. From S2TPR we can check the reducibility of catalyst. In case if it is only ruthenium or only metal, it's supposed to be reduced at low temperature. But if it is bonded with tin, means it is very difficult to reduce at low temperature, so it reduces at high temperature. So we suspect this high temperature reduction profile due to the presence of or formation of ruthenium 3SN7 alloy. So for better confirmation, what we did the TM analysis, transmission electron measurement. So in this case, what we did, we checked the high resolution TM image and capture one lattice pinch, and there are some lattice distance. We calculate the lattice distance. This lattice distance also can be calculated from XRD analysis, and we need to match it. So D value of 330 plane of ruthenium 3 essential crystal estimated to be 2.26 angstrom unit, which is close to the 2.23 angstrom unit of the corresponding crystal planes of standard cubic, this alloy phase RU3 SN7 crystal. In the TM image, this value exactly match with the corresponding value of D330 plane, and 2 theta value of 40.8910. It means that these pages are ruthenium 3 SN7 alloy confirmed. And in case of heterogeneous catalysts, most important thing is this site. We assume ruthenium 3 and SN7 alloy phase are the most active phase. So if you see the EDS pattern, this EDS pattern for ruthenium, SN, and zinc, and these are dispersed everywhere. So when the reactant acts up on the surface, this site is reachable. If it is reachable, means it can react and it can diffuse and it can produce the product and diffuse out. So it is necessary. So dispersion of active sites is most important, and it can be confirmed through the EDS mapping. And here you can clearly see that these pages are will disperse on the catalyst surface. Also, we synthesize the ruthenium team with the different proportion in different ratio, and in most of the cases, we able to produce the alloy phases. Butyric acid hydrogenation was performed in the continuous phase. Actually, this is laboratory scale. This is furnace, and in this case, what we did, we flow the butyric acid from here, and mm, catalyst was loaded inside of this furnace. There is one stainless steel reactor. At least catalyst was loaded inside on this part, and this is temperature sensor. So when the butyric acid passes through this catalyst, it can produce the product and condense here and collect here, and we take out this sample and analysis in different interval. And this is the GC chromatogram, means gas chromatography analysis. Here you can clearly see the separation of this product: butyryl, butylate, butanol, heptanol, and everything. So this reaction was performing vapor phase reactor. This is the picture for the vapor phase reactor system. From this experiment, we obtain the result. Sorry. Actually, this is the time on stream profile diagram from the obtained result. Here you can clearly see the butyric acid conversion, butanol selectivity, and in some time interval we use fermentation derived butyric acid. This reaction we run for like 3,500 hours continuously without any stopping. In case of batch, like there is some reaction time for like a 2-hour reaction time, 3-hour reaction time. But in case of continuous reaction, you know what is that? When we pass the reactant, when we pass through the catalyst or catalyst bed, it can produce the product, and we can like collect the product like tap water continuously. So there is no time, only time is related to the time on stream, means that catalyst stability. So this catalyst was stable more than 3 months. It provide almost 100% conversion and more than 98% selectivity and yield for the butanol without any deactivation. But at this point, we stop the reaction, and this is stem analysis for the fresh catalyst and used catalyst. Here you can see some catalyst deactivation, organic deposition, but the catalyst wasn't deactivated. So from this outstanding result, we believe that we develop a new nanocatalyst for hydrogenation of organic acid into desired product. So why this catalyst active and why this catalyst is stable? It is most important thing we must know to develop this catalyst for the commercial scale, from lab scale to commercial scale. So we found ruthenium 3 essential alloy phase was most active in hydrogenation of butyric acid into butanol. This is the schematic representation of our catalyst surface, tin oxide, zinc oxide, and ruthenium tin alloy phase. Acidic properties of tin oxide species interact with the carbonyl group and polarize it for the selective reduction. Tin oxide species act as a Lewis acid site, and it forms some like a partial bond with the pair of oxygen, lone pair of oxygen, and electronic. So this is one role of tin oxide, and another role of this catalyst is that interaction of tin with ruthenium. As you know, ruthenium is very active hydrogenation metal. So if we do not suppress its over hydrogenation activity, it can decompose and it can decompose, or it can produce some side products. So it is necessary to suppress its activity. So allowing of tin with ruthenium can suppress its activity and increase the specific activity towards the carbonyl group carbonyl and this group hydrogenation to desired product. And main advantage of this catalyst is that allowing of metal can provide additional degree of advantage through their strong geometric and electronic interaction, which could probably not them leach out in the reaction mixture. So because of these properties, it provide long-term activity and it did not deactivate it. We tested it for 3 months. We also tested the different catalysts from tin, ruthenium with different ratio, different support. So we obtain higher yield and higher selectivity for butanol using ruthenium to tin ratio of 1:2. Also, we develop a new catalyst, another catalyst, copper-based nanocomposite catalyst. It can also work efficiently for the hydrogenation of bio-based carboxylic acid into their desired product, such as adipic acid into epocaprolactam hexanediol, butyric acid into butanol, itaconic acid into 3-methyl beta-rolactone, 3-methyl tetrahydrofuran, fumaric acid into GBL and THF, succinic acid into GBL and THF, liolinic acid into GBL and MTHF. So this type of catalyst we already developed, and this is having like a potential industrial potential. For this topic, means only for this part, I would like to summary. Bio-based chemical processes are eco-friendly and economical viable, such as petroleum-based processes. Successfully developed bio-based conversion process for lactide and HMF into heterogeneous catalyst. Ruthenium tin on zinc oxide confirmed to be highly active and selective for vapor phase hydrogenation of butyric acid to butanol. And this catalyst provided its long-term stability even for the fermentation derived butyric acid. In case of fermentation butyric acid, the acetic acid co-produced with this butyric acid, and acetic acid is highly corrosive. So if it provides activity and provides stability in such acidic feed, it means this catalyst is really robust and very stable. So cubic nanoalloy phase identified as the active phase, showing high activity and long-term stability. And this candidate can be considered as a good candidate for other biomass derived platform chemicals from bio-based. Uh, uh, yeah, good candidate for the biomass derived platform chemicals into their value-added products. And here I would like to discuss the another integrated process for the production of pentanediol from xylene. So in this process, we start with the sugar, xylene and xylose sugar to produce perfluoro alcohol using sulfonated graphene oxide catalyst. And hydrogenation of this platform chemical perfluoro alcohol, we are able to produce the pentanediol with high yield. And for the separation, means separation process, we obtain 99.9% purity for this product, and this is odorless. And this product was very useful in cosmetic industry and preservative and cosmeceutical industry. So this process I divided into two parts. Here also I will explain in brief. Don't worry. chemical conversion of xylene to porphyral and its conversion into pentane-diol. So this is the schematic representation: xylene to porphyral, porphyral alcohol, and diol. Porphyral, it contain very active aldehyde group, and it is having like a wide range of it can produce wide range of derivative. So because of its wide range of derivative and eco-friendly properties, US Department of Energy approved porphyral as in top 30 platform chemical. And these are the key player which are player. They are producing porphyral and supplying worldwide. So our process means CRIC plus Active-1 process. Actually, CRIC transfer this technology to the Active-1. I also transfer this with this process to the Active-1. So xylene to xylose and this sugar into porphyral alcohol and then diols. So in this process, when we check the literature, there are some existence process using homogeneous catalyst and heterogeneous catalyst. In case of homogeneous catalyst, yield was low and it produced many side products. In case of homogeneous catalyst, also yield was like good, but not like that level. From porphyral alcohol, from porphyral. This is this is the hydrogenation reaction. This contain noble and transition metal catalyst. It can produce porphyral alcohol very easily with different range of temperature and pressure. And as you know, the optimum condition also depend on the catalyst. Means the different catalysts can produce same product at different optimum condition. In case of GWL synthesis, also we use we can use the porphyral. So here also, before starting this process, we also outline some problems in existing process and set our objective. Problems in synthesis of porphyral using heterogeneous catalysts are such as low product yield, long-term reactions, stoichiometry of catalysts. In most of the cases, like it is necessary to use 1:1 stoichiometry of catalysts, and industrially it is not considerable. It is very difficult to maintain the mass balance and the production, low temperature stability, and diffusion of pistol. And in case of homogeneous catalysts, separation, reusability, corrosiveness, safety concern, and some charge formation. So to overcome these problems, we set our objective and develop stable heterogeneous catalyst and process for the chemical conversion of biomass filters into porphyral with very high yield. So in this study, we also consider the graphene oxide. Graphene oxide is a kind of some reference material. Graphene oxide is a two-dimensional sheet of sp2 hybridized honeycomb carbon network, which can be obtained through the graphite exploitation, and it contains hydroxy, epoxy, and carboxylic group. And these groups are very active, so it allows its surface modification and become a catalyst for the various conversion processes. We did sulfonation through this process. We treat the graphene oxide with the chlorosulfonic acid and produce sulfonated graphene oxide. Same procedure we applied for the activated carbon and different type of carbon material, and utilize this for the our study and also our process. So formation of sulfonated compounds confirmed through the FTIR and X-phase analysis. In case of sulfonated graphene oxide catalyst, you can clearly see the stretching vibrancy, stretching peaks for the SO3 group and SO2 group. It means this sulfuric acid group is bonded with the catalyst surface, it did not simply adsorb. And same type of group, same type of peak you can see for the activated carbon, but it is absent on the graphene oxide itself. Also, XPS of sulfonated catalyst. Also, you can see the peak position for the sulfonic acid and sulfate. Oh, here I wrote in some Korean. Uh, it. I just want to say sulfonic acid and sulfate groups are strongly bonded on the catalyst on the material surface, means activated carbon as well as geo surface. So estimation of acidity also important, how much acidity is required, that we should come to know to the scale up of this process. For the identification of Lewis acid site and Bronze acid site, we did pyridine FTIR. From this analysis also we can calculate the qualitative Bronze acid site and qualitative Lewis acid site. But when I did this experiment at that time, that instrument wasn't that much advanced. So this is very old data. But the acidity, the concentration of hydroxyl group, carboxylic group, and SO3H group can be confirmed through acid-base back titration. And this procedure already reported in one of my research article, which already published in Green Chemistry. And sulfur density can be also calculated from the elemental analysis. So here you can clearly see the sulfonated graphene oxide contain some one means the sulfonic group concentration of 1.6 millimole per gram, and in case of activated carbon it is higher. But when we see the result, sulfonated graphene oxide give higher yield for the perfluorol than activated carbon. I will explain why exactly is this. In case of sulfonated graphene oxide, it contains the bronze acid site more than Lewis acid site. In case of activated carbon, it contains Lewis acid site more than bronze acid site. And this Lewis acid site are mainly due to the electron inductive effect of SO bonds in the surface of sulfonated complex. So for hydrolysis, bronze acid sites are most important than the Lewis acid site. So this technique can clearly identify which compound contain more bronze acid site and less bronze acid site, and which contain more Lewis acid site. But it is not like only this compound can generate more bronze acid site and it cannot. It can also generate more bronze acid site, but the technique will be different. We also tested this catalyst for the reusability, means after one reaction we just simply filter it out and charge for the next run. We tested it for 5U recycle, and it provide good yield up to 5U recycle without significantly loss in activity. Also, when we check is our SO3H is leached out in the reaction mixture or not, we found a minimal leaching of SO3H, maybe some SO3H on the surface, just adsorb on the surface of the catalyst, so that maybe come out in the reaction mixture. But it is very very low, very ppm level. I can say it is only ppm level, so it slightly affect the catalytic activity, but not significantly. Also, we optimize the reaction parameter, means when we do we start how much catalyst loading is necessary, how much temperature is necessary, and what could be the reaction time. So that first we need to optimize. So we check this reaction with different catalyst loading, and once we confirm the catalyst loading, we check the mm, uh, different reaction time and different temperature. Actually, this is temperature data. This is not a time data. This is mm, mm, I just miss and so in order to find out why this bronze acid site or is there any other site which are important for this reaction. So actually there are on literature we found it is published in Langmuir. So they they evaluated this synergetic effect of hydroxyl group and SO3H group. We also believe this effect is synergetic effect of hydroxyl group and SO3H group in our case. What they did, they tested amber light and Nepean shock and checked the absorption of sugar. Also, they tested neobic acid uh, for the absorption of sugar and check the reaction. Amber light and Nepean shock, these are the reagent catalysts. This contain mainly sulfonic group, and neobic acid contain mainly hydroxyl group. In both the cases, it did not perform reaction. It means perform the reaction. It means both groups are necessary. So in our case, what we did in our graphene oxide, it means what I design, what I synthesize, it contain hydroxyl group and sulfonic group. We protect this hydroxyl group by treatment with methoxy trimethylsilane uh, uh, using toluene at 80 degrees Celsius, and the protection was confirmed through the IR already. And when we tested this material, so we also obtained very low conversion and low yield for the product for the um, uh, desired product. So it means for this reaction both hydroxyl and sulfuric groups are important. From this study we demonstrate for lab scale, and we believe the catalysts which contain hydroxyl group and SO3H group can produce our targeted product, perphenol alcohol or perphenol from xylene. So after formation of perphenol, we set an experiment for its conversion into 1,2-pentane diol, and we also design catalyst nicotine zinc oxide, ruthenium zinc oxide, and we produce this pentane diol with very high yield. So this paper already published in some ACS Sustainable Chemistry Journal. So pentane diol is very useful in cosmetic industry. Pentane diol market value at UCC 121 million in 2019 and expected to grow at CAGR by 8.75% during forecast period of 2020 to 2027 to reach USD 175 million in 2027. Actually, this is the just estimated. It was estimated in 2019, but now it is higher than this value. So xylene to perphenol alcohol and its hydrogenation derivative. So xylene to perphenol I already discussed. So this perphenol and perphenol alcohol hydrogenation using heterogeneous catalyst can produce this diol product, and these are useful for the polyester, polyurethane, fungicide, inks, and mainly in the cosmetic industry. Here also we outline some problems in existing processes and set out objectives. So our objective to develop stable heterogeneous catalyst and efficient process for the chemical synthesis and conversion of bio-based platform chemical into value-added chemical with very high yield. This is our main motive and main aim in our industry, and this is the aim for any bio-based industry. So when we check the literature, when we check the literature, we found the combination of metallic site and basic site are recommended for the pentanediol formation. Actually, there are some literature. There are some literature using heterogeneous catalysts, but this literature or these processes having some limitation for the commercial scale. For study, these are okay, but for commercial scale, it need to be through several points and several fundamental points. So in this case also we utilize ruthenium zinc oxide. Actually, for the a commercial scale, we use different catalysts. But this slide I have taken for the just for the presentation, because this is not our actual catalyst for the commercial scale. Our catalyst was different. Our catalyst is different. So I already explained the identification of ruthenium 3 alloy in catalyst. We utilize this catalyst in this reaction also. From XRD pattern, you can clearly see the formation of alloy phases. In this case, in this study, what we did the in situ XRD analysis. In CRICT, we have a XRD machine which can be operated at different temperature, from room temperature to 800, not 800, 700, maybe around 700 degrees Celsius. So in this case, we observe the formation of alloy from from the process of reduction from room temperature to 420 degrees Celsius. When we reduce it from 330 to 420 degrees Celsius, we could not obtain any alloy formation. But when we keep it for the annealing, means we stop the hydrogen at this stage and flow only nitrogen, and allow it for the intermetallic reaction transformation, we found at this a step. We found the alloy formation at this step. Also, it was confirmed through the T-pair analysis, which I already explained in previous slide. Here also, we capture some lattice pinch and calculate the lattice distance. And also, we check the dispersion of this nano-alloy phase everywhere. So, it is easily reachable for the reactant and and for reaction, also disruption of product. So these are the physiochemical properties of ruthenium tin catalyst, such as BT surface area, CO2 TPT, ammonia TPT, H2 chemisorption. So in this reaction, the metallic sites, means alloy phase as well as metallic site, and basicity most important. So basicity of this catalyst was calculated through the CO2 TPD analysis, and it was very good. It was reasonable in case of ruthenium 1:5 ratio. It provided a high yield for the pentanediol. So probable reaction mechanism also calculated through the DFT analysis. DFT analysis can calculate the energy level and energy level, absorption level, and which can demonstrate the path for the reaction. So from this study, we believe on the probable role of ruthenium tin zinc oxide. I mean, each component in this catalyst. In case of zinc oxide, adsorption through hydrogen group on basic support, tin oxide species polarization of ether oxygen, aldehyde oxygen with Lewis acid site of tin oxide species, and alloy and metallic ruthenium, hydrogenation of aldehyde. Also hydrogenation of unsaturated site from the unsaturated site over this metallic site, and the ring opening over this alloy site. Here also we believe that alloying of metal can provide additional degree of advantage through their strong geometric and electronic interaction, which probably not them leach out in the reaction mixture during liquid phase or vapor phase reaction. So this is DFT calculation result we evaluated, and we believe on this. So this experiment was performed in batch type as well as in vapor phase system. So we tested the several catalyst system, and we found ruthenium to tin ratio of 1:5 and give best result. High yield for the pentanediol, around 84 to 85% of pentanediol from peripheral alcohol. In this reaction, we use IPA as a solvent, isopropyl alcohol, and also we tested other solvents, but the result was excellent in case of IPA. This is why? Because the hydrogen solubility is very good in IPA than this tested solvents. Here also we optimize the reaction condition such as temperature, pressure, and time. So reaction temperature of 140, pressure of 20, actually 30 to 35 bar, and reaction time of 6 hours is optimum using this catalyst system. So actually this catalyst, actually this study we perform for the publication purpose, but for commercial we have like a different study which is already commercialized, and industry, China industry already producing this pentanediol from Biomass, peripheral and peripheral alcohol. And in that case, the catalyst system is totally different than this. To check the resistibility, to check the catalyst resistibility, we tested this resistibility test at 100% conversion level for 5 times and 30% conversion level for the 3 times. To check the stability of catalyst, the low conversion level test is recommended, because it during like a low conversion level, the concentration of reactant and product is like it's more concentrated. So this is the like a good test. I mean, good test means a good atmosphere to check the catalyst stability. In case of 30% conversion level, also it provide stability up to 3 recycle. We did not test it further, and that is enough to believe this catalyst is like a robust and reusable. Also, we characterize the used catalyst. This one is A is the fresh catalyst, and this is the used catalyst. All the pages are present on the XRD pattern of both catalysts. It means catalyst can be used reusable further. But we observe some organic and coke deposition. It is very obvious when we deal with the biomass compound. So here I would like to conclude my today's presentation. So we successfully developed integrated catalysis process for peripheral from xylene and its conversion into pentanediol. Synergetic effect of bronze acid site and hydrophilic functional group in multi-layer graphene oxide, mainly responsible for the selective decomposition. Synergetic effect, we believe that like a catalyst must contain hydroxyl group which can adsorb the feedstock, I mean glucose, and it can allow to decompose for sulfonic group. Sulfonated graphene oxide offer reusability with little loss in activity. And ruthenium zinc oxide confirmed to be highly active and selective for the hydrogenation of peripheral into pentanediol. And synergetic effect of ruthenium-3 SN3 alloy pages and basic site of zinc oxide found in selective hydrogenolysis of peripheral into pentanediol. Here, actually, throughout this research, I able to publish these publications and patent. And I would like to say thank you for your kind attention. So if you have any question, I'm happy to answer all of your question, or you can write me email anytime, so I can also reply to your questions. Thank you very much.
Thank you, Professor Praveen sir. Thank you so much. Participant, the forum is open for question, answer, or the discussion. You can please ask any questions of the QD to Professor Oprah. Please, anyone, that will be really appreciated.
Thank you, sir, for your wonderful presentation. Sir, I have a question. When we use a
Okay, thank you,
catalyst
sir.
like
For the
heterogeneous catalyst, sir, does it
Yes.
change its stereochemistry during the course of reaction?
Yes.
Sir, what about stereochemistry of catalyst during its reaction?
Actually, stereochemistry means in this case, actually, this catalyst is not chiral. So, actually, in case of lactide production, D type and L type usually produce. But we just rely on the starting material. When we take the L type, we produce L type, and when we take the D type lactic acid, we produce the D type lactide. In this, actually, in case of heterogeneous catalyst, if you wanna develop the catalyst which can maintain the stereochemistry, so you need to be functionalized with some chiral functionality. But in case of heterogeneous catalyst, it's not quite obvious. When you deal with the homogeneous catalyst, it is possible.
Thank you, sir.
Yeah.
Hello.
Yeah.
Yes, sir. Sir, nice presentation.
Thank
you. I have one or two questions that
Okay.
how can one catalyst selectively produce multiple valuable products simply by changing or altering the reaction conditions?
Okay. Yeah. Actually, I just go with one example. In this case, actually, when I deal with the liolinic acid using same catalyst, copper silica, so reactivity of reactant, obviously like a different with the different reaction temperature. In case of liolinic acid, when I test it at low temperature, I able to produce only diol, pentane diol. But when I tested it at more than 265 to 300 degrees Celsius, I produce methyl tetrahydropiron. Same like when I test it at a low pressure, I obtain GVL, and high pressure, I obtain methyl tetrahydropiron. So it only depend on the like a diffusion and the bond formation. Some catalysts contain like a different, usually heterogeneous catalysts contain oxyfunctional group, hydroxyl group. So some groups can adsorb, means some group can adsorb at a very mild condition, and some group can activate at high, a very high condition. So that depends actually, but it can produce the product with different amount optimum conditions. Same catalyst can produce multiple product. That is possible.
Yes.
Only
Another one question is that
yes.
Can agricultural residue becomes the primary feedstock for future chemical industries?
Yes. Actually, in last example here, integrated process for pentanediol from xylene. So when we transfer this technology to one industry, industry, YINO, China. It is very famous industry for the pentanediol. What they are doing, they are buying agriculture residue. In case of corn, they just buy corn store from the farmer, and they cut it and they utilize it for energy, from energy to feedstock. Means they're producing even electricity and bio-based chemical from this biomass. So it is quite possible. And in most of the industry, sugarcane, most of the industry for ethanol production, people are using sugarcane. People are using bamboo, not from food, but from waste you can utilize. There are a lot of research going on, and it is quite possible.
Yes. Thank you. Thank you, sir.
Yeah.
Sir, good morning, sir.
Yes.
I have one question. Sir, can you explain that Lewis acid site experiment?
Pyridine IR, you mean?
Yes, sir. Yes, sir. Estimation of acidity. Yes.
You mean estimation or
No,
pyridine?
no, sir. I just wanted to know the experimental procedure, how we can perform this.
Okay, I will explain this. So first, what you have to do, like make the pellet of their IR instrument. First step is the most important step is the absorption of pyridine under vacuum atmosphere. First, what you have to do, you have to make the pellet of any sample, whatever sample you wanted to analyze, you can just make the pellet of this sample, and that pellet you can just keep or place in some IR cell or inert atmosphere. Inert atmosphere means that uh, you just first take out the vacuum and just place inside and create the pyridine atmosphere for a short time. So that molecule just absorb it. Okay, that molecule just absorb it and then heat it. Heat it means not outside, just uh, heat it, and it will release the absorbed pyridine IR, and whatever the absorb, it will stay with the catalyst surface, and then you can analyze the IR. So you can get this type of pattern and pattern from FTIR absorbance. So here you can see the bronze acid site peaks appear at 1633 centimeter inverse, and Lewis acid peaks appear at 1457 1503 and 1610 centimeter inverse. So it is possible.
Sir, how we decide that at this wave number it is Bronsted acid sites and Lewis acid
Yeah,
site?
actually, it's a good question. It is already reported since long time. Like it is already reported in since long time. It is not like my estimation. It's already reported since this analysis started. So these are like a standard value for the bronze acid site and Lewis acid site, I can say.
Okay.
Thank you, sir.
Yeah.
Yes, anyone else? Anyone else has any queries? Final call for the question, either we can conclude the session. Sir, I think there are no queries or the questions. So if you could permit, shall we conclude, sir?
No problem, sir. Thank you very much. Thank you very much for the invitation and allow me to present. Actually, I am an industrial person. I'm not academic person, but it was like my honor and my pleasure to be here. And
Sir,
It's our honor and pleasure, sir. Thank you so much. I mean, I
thank
could see so many messages that it was very informative and excellent lecture. So thank you so much, sir, for
thank
sparing the valuable time for giving us, sharing your knowledge with us. Thank you so much.
thank
sir,
you.
nowadays, as you have told that you are the industry person, so nowadays, the higher education institute, the industry has become the integral part of higher education institute in terms
Right.
of this internship and the curriculum designing also. Because what happened, the ranking framework as well as our curriculum integration has lot of potential from the industry, and the skill component that has been integrated in our curriculum, that having a lot of paying more emphasis towards the industrialist or the academic industry collaboration. So we are really thankful to you for your precious time and what the current scenario is going in the industry, and how can we integrate that kind of research that will be required for our industries as well as our societal development. So now I request Dr. Mali sir to please propose vote of thanks for current session, and then we will go for the next session. Dr. Mali sir, please.
Yes, sir.
Yeah, sorry ma'am, it's Dr. Manisha Mali, please ma'am.
No, it's okay. Good afternoon. Myself, Dr. Mimansha Mali, Adhyapak Sahak at Sir PT, Sarvajanik College of Science, Surat, Gujarat.
On behalf of all the participants and UGC MMTTC, San Garde Baba Amravati University, I extend my sincere gratitude to Dr. Praveen Upre sir for his insightful lecture on catalysis for sustainable chemical processes from biomass conversion to green chemical manufacturing. Sir, your valuable knowledge and research experience have greatly enriched our understanding and sustainable and green chemistry. During this session, we were able to understand about biorefining and its function. Sir, thank you, sir. I would like to thanks to the director of Dr. Mohammad Atik sir, course coordinator Dr. Manisha Kodape madam, Ankit Thakur sir, and all entire team of UGC MMTTC of San Garde Baba Amravati University for organizing this refresher course and providing us with such an inspiring learning opportunity. Finally, I thanks all the participants for their active participation and enthusiasm which made today's session very successful. Thank you, sir.
Thank you so much, Dr. Mali ma'am. Thank you so much. And thank you, Professor
Thank
Upre
you
sir.
so much, sir.
Thank you. Thank you, madam.
Thank you so much, sir. Thank you.
Thank you.
And with the kind consent of Professor Upre sir, I would like to declare that this particular session will be over here and we will going for the next session. I think our next resource has joined. Thank you so much, sir. Thank you so
Thank you,
much.
sir.
Thank you, sir.
Yes, so I think our next resource person, Professor Deshmukh sir, is with us. Hello, Dr.
Sir,
Deshmukh
yes.
sir.
Yeah, am I audible?
Yeah, sir, you are audible, sir. If you could permit,
Yeah.
shall we go for the next session?
Yeah, please, we can.
Yeah. So, friends, good afternoon once again. First of all, I request Dr. Mitali ma'am to please introduce our guest in brief, and then we will start with the next session. Dr. Mitali ma'am, please.
Yes, sir. Good afternoon, everyone. On the behalf of UGC MMTTC and Sant Garge Baba Amravati University, organizer of this refresher course in chemistry, it is my great honor and privilege to introduce our esteemed speaker for this session, Dr. Diwal S. Deshmukh. Dr. Deshmukh is currently serving as an assistant professor in the Department of Chemistry at Sri Shivaji College of Arts, Commerce and Science, Akola, Maharashtra. He earned his PhD in organic chemistry from Institute of Chemical Technology. His research work primarily focuses on transition metal catalysis, carbon hydrogen bond activation, heterocyclic synthesis, and sustainable organic transformations. Dr. Deshmukh has made valuable contribution in the development of green and efficient synthetic methodologies for biologically important heterocyclic compounds such as isoquinolines and quinazolines. He has authored several research papers published in reputed international journals and a book chapter published in Springer on sustainable carbon hydrogen bond activation chemistry. Dr. Deshmukh academic excellence has been recognized through numerous achievements, including Best PhD Thesis Award from ICT and selection as a Summer Faculty Research Fellow at IIT Delhi. He has also been awarded prestigious UGC BSR Junior and Senior Research Fellowship. Apart from his research accomplishment, he is an enthusiastic educator and mentor who continuously inspires students and young researchers through his dedication to scientific research and innovation. Today, we are privileged to have Dr. Deshmukh among us to share his valuable insights and expertise. I am confident that his talk on research methods and tools in chemistry will be highly informative, inspiring, and intellectually enriching for all of us. Please join me in extending a very warm welcome to Dr. Diwal S. Deshmukh. Over to you, sir.
Okay, thank you, Mitali ma'am, for the kind introduction. Let's start with the sharing. Just let me know, first of all, whether the screen is visible.
Yes, sir, it is visible.
Okay. Yes, sir. So, good afternoon, everyone. For this session on the research methods and tools in chemistry, first of all, I would like to thank the organizers for this opportunity of the for interaction opportunity with all the participants in the refresher course, especially Dr. Kodape ma'am. So I'm Dr. Deval Deshmukh. Actually, I'm working as an assistant professor at J.D. Patil Sanglutकर Mahavidyalaya currently. And my research topic is research methods and tools in chemistry. So as we know that, as being a faculty member, all the faculty members are being involved in the research. So as it is mandatory, or we can say that it's a very ingredient, what we can say the component of our academic career. So when we do the research, there are several steps involved, and straight from the research ideas, then literature survey, and when we perform the research, and at the end, there is the concept of the publication, and after that, research visibility. So in every step, we have to perform some task in the research, and for this task, or for every stage, there are tools available, because as we can see that in the previous era, the research was conducted by the traditional methods. So we have to go to libraries, and after that, the things changed from libraries to the web or the internet. And now there is the era of the artificial intelligence, and in this era, we should not lag behind, considering all the technologies, or we should cope up with the whatever the work is going on globally. Okay, so before starting to the actual tools, or what we can say that uh, before just seeing the tools, we should consider, or we should get some basic fundamentals of the research methodologies. So first of all, we will start with the quantitative matrix. Some of the concepts must be not totally novel for you, but for the wider audience, we should cover the some basic fundamentals, and then we will go to the tools. Okay, so here, as we know that when we publish any work as a researcher, so there is quality of work, or what we can say that there is impact of that particular publication, and this impact is measured by the quantitative matrix. So whatever your work, or whatever your publication is there, so we can consider that there is evaluation of your every work, and this evaluation is measured by the quantitative matrix. Not only authors, but your institute, your journal, then your research paper, everything, or whatever your book chapters, your review articles, everything is evaluated by some matrix, and these matrix are very important for the application, or what we can say that what we can predict from these matrix is the quality of your work, the impact of your work, the influence, and as well as it is also very important as far as the visibility of your work is considered. So as I already mentioned that there are four kinds of metrics as far as the academic publications are concerned. So there is institutional matrix, as I said, then journal matrix, author matrix, and article matrix. So one by one we will cover this. So we know that whenever we publish a paper in a particular journal, so everyone asks what is the impact factor of the journal, or what is the quality of that journal. So basically, for journals, there are two major metrics. First one is the journal impact factor. This is mostly used by the Scopus and all. So in journal impact factor, we just measure whatever the citations your article got in the last 2 years. Similarly, there is the one concept of the CITE score, in which we consider the citations in the last 4 years. We know the concept of citations. When we publish the research paper, how many other research papers use our paper as a reference, so it is considered as the citation, and this is very basic concept. So all over the journals, or these matrices are considered by simply the number of citations you got for your paper. Okay, so it directly, or what we can say that it ultimately decides the quality of your paper, because if other people are using your paper as a reference, then there must be something strong, rigid in your paper, which can be percolate further. So there are again two different matrices, that is the journal ranks and the source normalized impact. papers. So journal ranks are these are category wise. The journals are ranked according to their performance. And in case of the source normalized impact factor, because this is necessary, because there are different areas. Means if we can consider the mathematics and if you consider the life sciences, for the life sciences or the medical sciences, the one gets a huge number of citations automatically. But when it comes to the mathematics, so there are very less citations in the field of mathematics. So considering the particular area, there is normalized impact factor considering the area. So when we define the researcher as an author, we can consider, so there are some matrices for the authors or the researchers. So the very important first matrices is the H index. Or before that, we will see the total citations. Means as an author, how many citations I got totally. If I have published 15 research papers, and for the whole 15 research papers, how many citations I got, that is the very important matrix or very important number we can consider. After that, there is one important parameter that is called as the H index. H index means although you have published a number of research papers, but that is number of research papers, how many citations you got, or that is simply what, just a second. It is simply, let's take one example how to calculate the H index. So here we can consider that if I have published the 15 research papers, and out of 15 research papers, my at least 5 research papers are such that which are cited minimum 5 times. So in that case, when this y will equals to x, then 5 will be the H index. Again, the higher the H index, higher the quality, or what we can, the higher the impact of that particular author is considered. And another parameter is called as the I10 index. So if my one research paper has got 10 citations, so how many research papers got those 10 citations? So that is simply considered as the I10 index. For example, if I am having 6 research papers with the 10 citations, minimum 10 citations, then the I10 index value will be 10. So ultimately, the total citations, H index and I10 index, higher the value, higher will be considered as the impact or the quality of the particular research. So similarly, we can evaluate the research papers by the citation count, how many citations you got to the research paper. Again, the downloads and views. Many platforms on the website provide this data, that is the downloads and views. So one can consider with that also. So this also counts. After organization also, we are having, okay. So in case of the organizations, again, the total number of publications, total citations, then how many papers are published in the international level, national level, industry, academic. So all these things are considered as an institute. So when there is a competition, or what we can say, there is the ranking of the institute. So the citation data is very crucial in that case. So just we can consider the example, that is the benchmarking, the field weighted citation impact. This is the university ranking globally. So for this also, the number of citations your institute got is considered. There is one value for the global average, and you are considered below the average or above the average. So all is depends on the citations of your research institute. So as we know that the things are changed drastically when it comes to the research. Means we have seen, means we have at least heard the era of the alchemist, and today's era. I have already mentioned that the traditional approach of the research was very different. We can consider the previous generation, which was simply used to perform the research by simply pen and diary and going to the library, and then finding the journals and books and all these things. So the what we consider this has been started from that traditional way, and now there is the modern ways are available. That is, all the things are changed or shifted to the digital databases we are having on the internet. Initially, we used to do the manual literature search. Now, in last 4 to 5 years, or we can say that after the COVID pandemic, huge number of AI-powered research or AI-powered tools are available for the literature search. Even in our PhD also, we used to do the manual literature search, and months and months or a huge time was engaged or was vested for the literature search only. And after that, if we have a new concept, for example, in the organic synthesis, we have to perform in the lab. So there was a trial and error synthesis, means we have to try the reaction, whether it works or not. But nowadays there are some applications or some tools are available where you can predict whether the reaction will work or not. And there are several computational tools are also available. So paper notebooks are again changed to the electronic lab notebooks, so you can manage your all data using that. And the manual citations is changing to the citation managers. We will discuss about it. Okay, so the main challenge to the today's researcher is the avalanche of data. Means thousands of research papers are published, being published day by day. Means if you consider your specific topic, there also means if you search on the Google or any other searching tool, so there are thousands of papers available still now. So the main issue is that finding a proper or the specific paper of your interest is the main challenge. And to cope up with this challenge, we are having several tools. So we will get it one by one. So when we use these tools, so what is the advantage? First of all, it increases the speed and productivity of your work, because I have mentioned earlier that previously we have to spend weeks and months for the for only the literature review. After that, the using the recent tools, it increases the accuracy as well as the designing of your concept, and it also helps in the collaboration and reproducibility. So let's start with the literature survey. Everyone knows what is the literature survey. We need to do the literature survey before starting any research. And it's a very crucial point, I must say, because it decides the further journey of your research. And also it decides the quality of your research. Whatever the literature survey you do, and the further work will be totally depend on the literature survey. And that's why it's very important. It identifies the specific research gaps, eliminates the risk of duplicacy, because many times it happens that you do certain work, and if you have not did the literature survey, that work it is probability that that work is already existed, and the efforts you have and the time you have spent in the laboratory, it goes waste. So before starting any new work, any novel work, you must check the duplicacy report, or also to produce the context, or to generate the context, you must do the literature survey. So when considering the literature survey, there are two tools which are widely known, widely used. That is the Scopus and Web of Science. Everyone must know the Scopus and Web of Science, because in the premium institutes, these are very widely used. And everyone knows if you have published any research work in any particular journal, then people ask whether the journal is Scopus indexed or no, or what. So it is the indexing site also. And for the literature survey, these are considered as the best tools from years and years. Means before the AI era also, these were existed, and these are extensively used by all the researchers. The main issue with the Web of Science and the Scopus is that these are the subscription-based sites, because it require to pay almost lakh of rupees annually, and these are paid by the institution. So if you are having the institutional access, then it's okay, you can go for it. But what in case of you are not having the institutional access? So the open sources, or the open what we can say that the free of cost, or is free of cost portals we are having, that is the Google Scholar and PubMed. So Google Scholar is very widely known, very well famous for the literature survey. You can simply put any keyword over there, and it will give you thousands of papers related to your particular keyword. So Google Scholar, there are profiles also of a particular person. As an author, you can also search the profiles, and you can also search the literature on the Google Scholar. PubMed is also there as one of the options, although it is dedicated, or it is well specialized for the medicines and the biological sciences. But a huge number of chemistry databases also available on the PubMed. So considering this, the next tool comes as the Science Direct. This is one of the favorite tool of mine. So we will see in short what Science Direct tells. So just tell me once whether the screen is appearing, means I have opened browser.
Yes, sir.
Yes, sir.
Okay. So this is the first interface of the Science Direct. Here we can see Science Direct. The best thing about the Science Direct is that it is open access, means some of the for some of the things you have to pay something, but most of the things we can perform the literature survey on Science Direct free of cost. So this is the interface. Here you can simply type any keyword, or you can simply type the name of the authors, or you can simply type the name of the journal, and if you click on the search, it will give you the results. Although if we want to perform the advanced search, so there is one option that is okay. So here you can simply type anything, any related word. Okay, let's consider copper nanoparticles just for the example. Okay, and if you want to mention these particular terminology in a specific journal or book in a specific year with a specific author, so you can provide that. If you don't have to give this data, you can simply go with the particular keywords, and when you go for the search, it will give you results. Okay, so there must be some spelling mistake in the particles. Okay, so you got it. So in this way, we can get these research papers, and here is the and also the facility of the what we can say the filters, means you can filter these research papers by years, by the publication titles, by the subject areas, and whether these research papers are open access or not. You must know there are two type of research articles. One is the subscription based and one is the open access. So if it is open access, then it is easily available, freely available on the internet. If it is subscription based, then you have to purchase it from the publishers, or you must have the institutional access to get these papers. So as an individual researcher, we always try to get such research papers. If it is open access, then it becomes more easy for us. And if that is not open access, so we will see later. There is one technique how to get these research papers. Okay, so this is all about the Science Direct. Okay, again a very wonderful tool. Okay, moving further. So whatever the tools we have seen right now, these tools are what we can say that these are the traditional tools. Means I already mentioned that before the COVID era, or from last few decades, we are using these tools already. And now there is the era, or what we can say, there is the age of the artificial intelligence. And in artificial intelligence, there are several advanced tools which we can use for the literature survey basically. And there are some paid tools, there are some free tools, there are some what we can say the freemium type of tools. So open access is one of the semantic scholar is one of the tool, and another tool is the open alex. So here is the interface for the open alex. So it is again wonderful tool to get the research data, research papers. So here we can see that it is not a normal, it is AI advanced tool, what we can say. So this is the interface, and here we are having option whatever we require, whatever our research area, research topic, we just have to put the what we can say the keywords. Okay, and there are two options while asking the query to this particular tool. One is the Boolean, and another one is the semantic. When we use the Boolean tool, in that case, it will catch only the keywords, and it will generate the results which are specific to those keywords. So while using the Boolean, we have to very cautious while using the commas and or not. So these words should be used very carefully when we go for the Boolean option. So as it will capture exactly what we have provided and only the keywords we have provided, nothing other than that. Another option is the semantic. Semantic is more AI based concept. If you have asked it's something, or what we can say, a particular phrase you have or particular topic you have provided, then it will think like means AI, and it will it will auto consider by itself and produce you results according to him. Okay, so it will definitely, what we can say, that it will modify, or it will definitely think whatever we have provided and then provide us the data. So here are several options, that is the works we can find. If it is clicked on the work, then simply we have to type some keywords or some research concept here, and it will give us the data. After that, we can search the authors particularly. So if you have clicked on the authors, it will provide you whatever the research papers associated with that particular author. Then you can also enter the institution, and you can also enter the sources. Sources means the name of the journals you can simply introduce here, and it will give whatever the research papers are available with that particular journal. Here are more also entity types, but okay, so let's check with some. Okay, so I will give some command to it, that is isoquinoline synthesis using cobalt catalyst. Okay, so if I have given the command, and then I will change it to the semantic. Okay, so it will produce the results, and you can see how beautifully it has generated the database. Means here we can see the list of the research papers which are relevant, which are related to my particular query. So whatever the research papers here provided, means what we can see, that almost 100 of research papers it can generate. Okay, and the similar thing we will again try. With the Boolean operator, and let's check what are the results. Okay, so when I go on with the Boolean operator, so there are 16 papers, it is showing the specific one. And again, one of the more beautiful thing is that it is showing the graphs. So year wise, how many publications are there on this particular or specific research work, you can see here. After that, how many papers are open access, means almost 43.8% papers are open access, means whatever the results they have provided. So as I have mentioned earlier, if the paper is open access, you can directly go and download it or read it. So, and you can click on that. If you click on that, then it will provide the list of only open access papers. So that is also again a very good thing. You can screen it by the institutions, by the topics, by the type of articles, as a review article, as a research paper, or the editorial, or dissertation, or conference proceeding, whatever. So whatever the types, you can accordingly, you can proceed it, or you can screen it accordingly. Okay. So there are some more widgets also available. So if here we can see 5 widgets, but if you want to add or remove some of those, so you can do that also. So better way to explore it means the very short period of time, I can just introduce these tools. But when one goes to that particular tool and explore it thoroughly, that will be more fruitful, I guess. Okay, so you can download the data also. So in this way, the OpenAlex is one of the important, or one of the beautiful tool, which is AI based for the literature survey. The next tool, which you people might be known very well, that is the SciFinder. SciFinder is very popular tool amongst the organic chemist specifically, because when we consider the Scopus or Web of Science or some another tools, so we can give the keywords or the concept in the writing. But this is very important tool where you can simply draw the structures of the reaction. So one of the very widely used for the organic chemist. So here there is the option of the draw. If I click on this draw tab, so you can see whatever the interface appears, just like the chem draw. Here are several options, so I can click any reaction. Just like, for example, I am just taking the benzaldehyde, and if I want to check the reaction of benzaldehyde with aniline, I will just take again benzene ring, then one bond, then nitrogen. It will be considered as the aniline, and I will simply draw the specific reaction arrow. Okay. So if I have provided this query to the SciFinder, it will give me all the research papers till now published on this particular reaction. All the research papers in which this specific reaction has been maintained. So the best and most beautiful tool, that is the SciFinder, you can see here that I can see several research papers. I got almost 11,600 research papers on the similar reaction, although it is a very simple skip-based production. But whatever the papers or whatever the publications are reported on this particular reaction means, again, that is the beautiful concept, because you directly have to just give the reaction to the particular tool, and it will give the all the research papers in which this reaction is included. Okay, so here there are options. If I am having this particular list of the papers, again there are some filters. If I want the reaction as drawn, or I want the substructures also, so it will provide. After that, if I want the yield of the reaction, then there are several filters for the yields, then the number of steps, then so many filters are there. Reaction mapping is also there, then the catalyst which you use. So as per your requirement, as per your specific need, you can go for the several filters, and the research papers, whatever it is displayed on the what we can say this interface, that will be narrowed down. Okay, because in the very early presentation I have told you, there is the avalanche of the research papers, and if you want a specific research paper, you must use the filters in all these applications, all these tools. So if, for example, I want this particular paper, so just I have to click on the full text. Okay, full text, and then DOI and view all sources. So it will directly move to, or it will directly navigate to the original web page where the research paper is published on the particularly site of the publisher. So here you can go, and here you can check the other things, or the accessibility of the paper and the remaining things. Okay, so in detail you can see. Just remember that these are only the search tools. Okay, you can't get the full access papers here, but you can check the list of the papers, and later you can try to get those papers. Okay, so another thing is that, okay, so here is we again on the CAS draw this interface. So if I don't know the product, then what I did, I just have drawn the reactants. Okay, the two reactants I have drawn, and then I just put the reaction arrow and just left it. Okay, so whatever the product possibilities are there, then I don't need to concern about it, because whatever the results are produced, I can see the direct the results. Okay, so there are multiple what we can say the product formation is possible in the with these two reactants. So whatever the possibilities are there, all the possibilities is mentioned in the results. Okay, this is one thing. Another thing is that if I want to get one specific product, for example, I am here drawing the structure of, okay, indole. I want to prepare this product. Okay, and I don't know what are the reactants I should use, and just my target molecule is this, and I want all the research papers in which this is the target molecule. So this is also possible. You just have to draw the product, and then you will get all the results associated with the product. Okay, so I can see that almost 3,400 results are there. So I can choose and I can use the filters also. And this whole reaction also you can draw. So according to your need, you can go for it, means whatever you require. So again, the SciFinder is the best technique, best tool. And not only these reactions, in SciFinder, you can also search the keywords or the specific research topic, research areas, and it will give you definitely the good results. Okay. And another tool, the similar tool is the Reaxys. But again, the issue is that although the SciFinder and Reaxys are the most trusted tools by the scientific community, because most of the premium institutes, most of the reputed institutes use these tools only. And it will provide almost all, means whatever, if you have provided any query, it will provide all the results, means you can blindly trust on those results, because and nothing will be left in the results. So that is the beauty of these two tools. But the issue with this, again, we have to pay lakh of rupees for the subscription, and the subscriptions are get only by the institutions. Okay, so individually it becomes difficult. So the solution for that, I'm not saying that there are some tools which will totally replace the Reaxys or the SciFinder, but some things at least we can do with the structures. And the tool is the ASCOS, which is developed by the MIT. So here you can see the ASCOS tool. So this tool is developed by, I already said that, MIT. And here also you can search the reactions by drawing the structures. Or also you can provide the SMILES notation. Everyone must know the SMILES notation. It is the linear notation for the molecules, for the organic molecules specifically. Okay. So here just you have to provide the SMILES notation. Okay. So I have copied one, so I will just click. And if you are not having the SMILE notation, you can just go to the Google and search for the SMILE notation. You will easily get it. And if I want to search for a particular that molecule, here I just have to provide SMILE notation. If I am not having the SMILE notation, if I'm not getting, or I'm not able to generate the SMILE notation, then also there is the option of the drawing here. Just there was in the SciFinder. So the cane draw like interface is there. You can use it. So you can directly draw the structure by using like this, and after completion. Okay. So, okay. I will go for this molecule particularly. Okay. So you just have to provide this data, either the SMILE notation or you can draw the structure. And the beautiful thing about the ASCOS is that we know the concept of the retrosynthesis, which is specifically used in the industries, in the pharmaceutical industries, where you want to produce a particular product, a specific product. In that case, what reactants should I use to produce this product? So by using this tool, you can get at least what reactants you can use considering the previous report. So here I have mentioned this molecule, that is again the substituted isoquinone molecule. And if I want to know from which reactants I can prepare or I can make this molecule, I just have to click on this. Okay, and then you can change some models here, that is the Reaxys or another one. And when I click on the one step, it will give me particular this type of thing. Okay. So interestingly, you can see that this is my target molecule, which I wanted to prepare. And for this target molecules, whatever the reactants are available, or whatever the combination of reactants, I can see here. So I can prepare by these substrates, or by these substrates, or by these substrates. Okay. So there is ranking also, means whatever the maximum number of publications are available for a specific reaction route. So this is number one, this is number two. So I can go for it. So I just have to simply click on this number, and I will get the detailed reaction parameters of that particular or specific reaction. Okay. So here if I click on the calculate details and on this particular link, I will get the links or for the references, means from where this reaction has been taken. These are the links. I can simply click on the link and it will divert me directly to that particular web page from where this reaction has been taken. Okay. So again, this is very, if I want to know more about the reaction parameters, more about the reaction conditions, so I can go for it likewise. Okay, so any reaction you can grab whatever the reactant materials you are available. Again, I am repeating that this is specifically important for the industries, for the pharma industries, for the chemical industries, where they perform the product-based research. Okay, so this is one of the way. Just simply like the finder or the reaxis, you can simply put the structure of the products or the structure of the reaction, and then you will get the results. Okay, one another more important thing with the ASCOS is that there are some more tools available here, that is the utilities. So solubility prediction means if you are having any solid organic compound and if you want to check the solubility in specific solvent. So in the traditional way, what we used to do that you take the pinch of the particular compound and then tries with the various solvents and check the solubility. Okay, so these things are there, but nowadays in the modern AI era, we can use such tools where we can simply put the name or the smiles notation for the particular solute, and then we can enter here the smile notation for this solvent. Okay, these are easily available. The smile notations are easily available. You can draw also, no issue. And then you can check whether this particular compound is soluble or what is the solubility at the specific temperature. Means at the elevated temperature as at the room temperature, you can check whatever you want. Means no need to perform actually in the lab. You can get at least a prediction whether the solubility for the specific solute in specific solvent will work or not. Then the another another important tool is the solvent screening. Okay, so again, putting the particular solute smiles, means the particular compound smiles, and checking whether which solvent will work or what is the solubility in the solvent. You can check with several solvents. Here we can see that O is the smiles notation. It is simply only for the H2O. Then CO is for the I guess CH3OH, that is the methanol. So these are the smile notations. You can check. You can click on a specific solvents, or if you have put the smiles notation for the solute and considering these solvents, or you can add or remove some solvents also there, the temperature, it will simply produce a graph in which you can get the sense in which solvent the solubility of solute is more or less. Okay, so again, very important, very significant applications of this tool, that is the yes. Okay, so it's ASCOS. So this is one tool, and the similar tools. Okay, here what I have done is that because so many multiple tools are available for a specific what we can say the task. And rather than considering or rather than covering all the tools, I have just concentrated, focused on one particular tool, and remaining are the just examples. The similar tools are the IBM RxN for the chemistry. Okay, and again the SPIA is another tool in which you can do the similar kind of work as far as the structure of the reaction or the structure of the product is concerned. Okay, so here you can use this tool. Later, let's come to the patent, because okay, so we have completed so far the literature review with respect to the research papers. So here comes the patent search. We know that patent is also the very important aspect of the research, and if we want to check patents on a specific topic, specific area, we can use the Google Patents. It's a very widely used open access tool to search and to check the patents. Also, the SpaceNet is one of the tool which is basically what we can say or particularly designed for the Europe-based countries. Okay, so whatever the European patents are there, we can check it on the SpaceNet. So these are the tools where we can only search the patents. Means we will get whatever the with specific keywords or the topic. We can get the patents, no issue. But these are only the searching tools. So in the era of artificial intelligence, we are having more advanced tools as far as the patent search and processes are concerned. So one of the important tool is the lens.org. So here you will get some advanced functions regarding the patents. Also, the PatSnap developed by Eureka is again important tool. Here we will see the PatSnap. Here is the interface for the PatSnap or the Eureka by PatSnap. Okay. So we can see here, this is just a window for providing any query. You can ask it anything, just like ChatGPT or the Google Gemini. You can ask the questions and it will questions which are related to the patents, and it will provide us the results. Okay, no issue with that. The main functions or the main applications of this particular tool starts here. Okay, so you can go for the quick search. Just it will provide you the result just like the SpaceNet or the Google patents. So you can search here, you can find the solutions. Okay, we will come to it later. So if you are having any new innovation, okay, you are having new concept and you want to file a patent for that, the first important thing you should perform that you must check the novelty of the research. Means you have done anything, and if it is already known by someone else and it is already reported as a patent or the research paper, so there is no use of filing all these things. Okay, so first of all, you can search whether the work you are doing or you are going to publish is novel or not. So there is very important tool here, that is the novelty search. Here, if I have checked it on the novelty search, I can see here. I can see here again one window where I can simply write it down, whatever my requirement is or whatever I have done. Okay, whatever I did in probably in the single para or the main findings or the main claims I have to mention for my patent. So simply I can put here, and it will produce you the results. It will thoroughly do the literature for the available research papers, for the available patents. You can cross check, you can cross verify. It will provide you the list of all those patents, and the most relevant searches you can find specifically. And if your work is different from that, or if the work is publishable or patentable, you can definitely go for it. If the similar work is already existed, there is no point to do the further process. So before filing for the patent, one must check for the novelty search. So this is again important, one of the most important application of this Eureka. Okay, then FTO search option is also there. FTO means freedom to operate. Whether if I am performing what we can say that I am I'm drafting and submitting any new patent work, and if it is illegal to publish, what we can say, or there are some legal issues with it, or we know that in the various countries there are different rules, different legislatory systems. So for a specific country, we can search it where I can publish this patent, or there are some legal issues to publish and to submit this patent. So before submission, because there are several legal issues may rise later submission. So before the submission starting process, we can check the FTO search here, where we will get all the information regarding that, whether we can publish it or there are some legal issues and we have to resolve those legal issues, and then we can go for the patent publication. So Like this, if you are facing any issue with the patent filing or the patent drafting, patent writing, then there is another tool, that is the find solutions with the trees. If you ask the query regarding your issues with the patent drafting and filing, then it will definitely try to solve the problem related to the patents. See, the most important thing with the patent is the patent drafting, because we know that we have almost all of us has published several research papers. But my own experience is that publishing the research paper and publishing patent is totally different thing, because patent having a totally different language, totally different whatever their parameters. So I have published so many research papers, but when I gone to publish one patent, I just personally faced so many challenges, because there is some specific, what we consider, there is some specific language needed, specific pattern needed, and drafting the patent is really not a joke. So that's why people simply spends thousands of rupees for just a patent drafting. And here, this tool can also help you to draft the patent. So there is the option of the patent drafting here. You just have to provide it your raw data or whatever you have written in the rough. So if you provide it, it will definitely convert it to the patentable language, patentable formats, and that will be definitely helpful. Again, this is the freemium tool. That is some of the what we consider, some of the tools you can use free of cost. For some of the tools, you have to pay some rupees. But again, it depends on the need of a particular person. So whatever, as per according to your need, you can go for the premium access, or you can use the free versions of these tools. Are you getting it? Means whatever is going on, please still respond, because hello. Hello.
Yes, sir.
Okay.
Yes, sir.
I just wanted to know whether
Yes, sir.
means, yeah, okay, because it's like means one-way interaction is going on, and okay. Anyways,
Eureka is free access or free है और this paid है Eureka.
which one, ma'am?
Eureka
Just I
patent है.
mentioned Eureka is partially free and partially paid. Means if you want to search the patents, if you want to search the novelty, then it's okay. You can use it freely, no issue. But when the things comes for the patent drafting, then you have to pay for the particular means those tools. So it is premium type of version, we can say. So as per our need, we can use it. Okay. So next, after patents, there is one more tool where we can go for the research mapping. Means whatever the paper we are having, most of the times when we write the research papers, we are having very less references for a point. Means, for example, we wrote one particular sentence and we want at least 5 to 10 references for that. But many times issue is that we are having only 1 or 2 references ready with us, and searching those specific references, what we can say the back referencing and all, it becomes again difficult most of the times. So for that, to check the relevant papers, so we are having the mapping concept, research mapping concept, and for research mapping, there are some tools which we can use. Most of the tools are free of cost. This doesn't charge any cost. That is the lit maps. Then research rabbit is there, and also connected papers. So we will see one app here, that is the connected papers. So here, the interface for the connected papers, if we want to check the relationship of one specific paper with the other paper, or we want the relevant papers with a specific one, then we just need to put here the DOI number. We know the DOI of the research paper, that is the digital object identifier number. This is specific for a specific research paper, just like Aadhaar number in India. So here I just have pasted the DOI number here on the paper directly, and when I just click on this there will be generation of the graph or the research map. We can see that. So whatever the research papers are there, so here the connected papers I can see here. Okay, so uh, many times we require the relevant papers or the more papers in the specific area, or for the citations, for the references. So we can use easily this tool, that is the connected papers. Again, a very important tool. And again, the most okay, so these are free of cost available. So now you can use the research rabbit, you can use the connected papers, you can use this lit maps. So all these tools works almost similarly. So you can use any one of these tools. Okay. So the next important concept on one, I can say that one of the debatable concept is that is the academic drafting or AI assisted academic drafting. I'm saying it's the debatable because there comes the question of ethics. Should we use these techniques for the research paper writing? Okay, so that is the different concept. First of all, okay, we will discuss that point also. But first of all, we will just take one tool, that is HyperWrite here. Okay, so there are 2 to 3 tools I have mentioned here. Actually, 4 tools. The first one I have mentioned here, that is the Genie.ai, which is very well known, popular tool for the research drafting and writing. After that, HyperWrite we are going to see. Then one another tool is that the Yomo AI. Then the SciSpace is also there, one of the famous tool for the research drafting. So here, okay, so we will take a look for the HyperWrite. So this is the tool for the research drafting. We will definitely discuss what should we go, means what should we consider, what should for which task we should use this tool, or for which task we should not use this tool. Okay, we will definitely discuss over it. But before that, let's have a look for this particular tool here. Again, we are having one window for the simply asking the question. Again, it's similar like ChatGPT, Google Gemini. You can simply ask the question, it will try to give you the scientific answers regarding that. So this is one tool, but the main tool we are going to focus, main tools we are going to focus, these are mentioned here. Okay, so below you can create the document. You just have to click on particular tab for the creating document, and here there is a blank document. If I write whatever your research requirements are there, or whatever your research drafting requirement is there, you just have to write down one sentence related with your research, or what we can say, only the title related to your research, and then it will automatically complete the sentence, automatically complete the para. Okay, so for example, I'm just writing one sentence here for the understanding. So green chemistry is one of the important way for the synthesis, or we will say the necessary way. Okay, necessary way for synthesis of heterocycles. Okay, I have just mentioned, or I have just typed one single line. Okay, and what are the results after completion of that line? I will just enter the space bar, and then it will automatically complete the sentences. So here we can see that how can we use the green chemistry principles to synthesize heterocycles. Okay, if I agrees, I will simply go forward. Okay, so here whatever the draft or whatever the paragraph we required, it will automatically complete. Here we can see I am just giving the space bar, and after space bar you have to just whatever it has written, then here are options. Okay, you have to just accept it or not just by going further, again giving space, and it will definitely complete the whole para and whole sentences for you. You just have to cross check once by reading. Okay, so so many tools are there which can do for it. This particular task is called as the auto completes or the auto completion. So so you can use this tool for the drafting. Also, if we want the references, because this is only the draft and we want references for the research paper, so here is the option for providing the references also. So if you have if you click on these references, so there will be generation of references also in the right side. Okay, so here you can see there are some references which are generated. You can use these references. Okay, so this is one of the tasks you can do using the hyperwrite. You just have to provide one title. You just have to provide one initial sentence, and it will automatically complete the drafts and paras for you. Okay, so this is one of the application. Another one is the you can rewrite the content if you are having any rough draft made by you. So probably you are having the doubt that whether the information I have incorporated is correct or it is grammatically correct or not. So you can simply use this tool, that is the rewrite content. You have to upload your document or you can paste your whatever the content is there, and then it will polish it for you. It can rewrite for you with the references. So this is again what we can say the important tool. Now the question comes that whether we should use this tool or not, because again the question of ethics is there, because writing the research paper is not a joke. Means I know that for writing particular a G9 research paper, Scopus indexed for Scopus index journal, you have to just take efforts for months and months for the drafting only, because it requires huge efforts. It requires huge literature, huge citations, and all these things. But if it is providing you directly or ready-madely, so in that case, whether it is acceptable or not. So the answer for this question is that when you are going to submit your manuscript written by this way, written by such tools to us to any reputed journal, any reputed or any Scopus indexed or Web of Science indexed journal, then it will be rejected in a very first step. It will not even go to the editor. Okay, the reason is that we know all that for a specific research papers there is need we need to check the plagiarism. So initially there was only one concept of the plagiarism, but later the concept of AI detection is also there inbuilt with the tools like Turnitin or Authenticate, which are widely used by all the scientific community throughout the globe. So these tools having the AI detector function also, which will detect whatever you have written in the research paper by using the AI tools. Okay, and it will reject your paper at a very in a very single step. So there is no issue that, or there is no point that you should use these tools for the publication purpose. Okay, so one should not use, because we have tried means several times. Although you have generated the content by using these tools and then paraphrased it, modified it, still the Turnitin is capable to detect the AI content, although if you have modified it. If it is the original AI content and you have modified it, still the Turnitin will catch it. Because in the last few, what we can say, in last few months, the Turnitin has upgraded itself to such a monster level that although if you are not used or if you have not utilized the AI tool, still it will detect some content that is called as the false positive. That is different part, but I am saying that it will definitely catch the AI writing. So there is no use. So where we can use these such tools. So for the daily academic workings, or what we consider daily academic tasks, we can use this for the report making. We can use this, no issue. At least for the draft, what we can say, if we are writing the research paper and you have to develop the outline for that, so for outline development also you can use it. So for daily tasks you can definitely use these tools, but for research, what we can say, the research publication purpose, it is not recommended at all, and it will not accept also. Okay, so this is about the AI assisted academic drafting tools. The next the next tools we are seeing here, that is the manuscript polishing and refinement. Okay, so this tool we can use. That is, we know that although we are all are academic persons and all are teaching to the senior colleges, but still when it comes to the grammatically correct English writing, then so many of us faces the issues. Okay, so in that case, whatever you have written in your own rough draft, and you want to make it polished, or you want to make the corrections grammatically, so these are the tools. You can use the Trinca, you can use the Rightful is you can simply offline version is available. You can simply plug it with your Word file. Okay, after that, Paperpal is there. Then DeepL Write, Grammarly is well known for the general consideration. Then one of the important tool is Quillbot also. So here we will see the Quillbot, that is the interface. Quillbot is also widely known and very popular tool. Means most of the functions of the Quillbot are freely available. So what you can do with the Quillbot, what we were seeing the manuscript polishing and correcting the grammatical errors or the grammatical mistakes. So if you have written ethically, hold the research paper, and you want to submit it to the editor, after, so before submission, we have to do some final checks, and in those final checks, the considering the grammatical mistakes is one of the important tasks. So for that we can use the Quillbot. So here you can simply paste your material, whatever, paste your content, whatever it is, or you can simply upload your Word file here, and it will provide you the corrected form of your content. Also, you can do it for the paraphrasing. Means some of the content, if you have taken from some other sources, from the previously reported some research articles, and if you want to modify it, if you want to check it to avoid the plagiarism, in that case the paraphraser is a tool which you can use. But again, there is the issue of the ethics. Means the doing these things manually is considered as the best, as per as your legacy, as far as your whatever the ethics is considered. But in some cases, you can take the help of paraphrasers. Then AI humanizer is also there. As I have mentioned earlier, that if you have generated any content from the from the AI tools, and if you are using it as it is for the publication purpose, it will definitely not acceptable at all. Okay, so what people do? People do the use the AI humanizers. Means they simply generate the content from the AI tools, then they simply copy it from there and paste it here and try to make it humanize. Means the main target is to, or the main purpose is to avoid the AI detection by the tools like Turnitin. But what happens, again, I have experimented a lot in this particular sector. I have used several tools for the AI humanizers, and what was my conclusion was that although you use any AI humanizer tool, it will definitely be detected in the Turnitin. Okay, because here you will do some humanization. It will show that your content is reduced to only 10% AI, 90% human. But when you upload the same manuscript to the Turnitin, it will show that your content is AI generated. Means nobody or no tool can beat the Turnitin. So that's why there are several AI humanizer tools available in the market, and everyone do the marketing that we can assure that we can convert it 100% to the humanized content and all, but nobody can do the 100% humanization because Turnitin is way ahead of all these tools. So this is not recommendable to use the AI humanizer and all. So AI detector also the same in case of the AI detector here. These tools will show the 25% AI detected, but when you go to the Turnitin, it will show the original result that is 60%, 70%. So these things are so using these tools. So what we can say, uh, we should use it very carefully, very precisionally, and for the specific tasks only. Again, some reference management ecosystem is there. That is, several reference management tools are available in the market because when we complete the research paper, for example, we have written one review article, and we know that the review article having the so many references, at least 150, 200 references, one good review article may have. If you have submitted one review article to a specific journal, and suppose that your article is rejected by the journal, so in that case, for the first or for the prior article, you have to do all these references or the citations in a specific format for according to that journal. So doing all these things manually means changing all the references one by one according to the new journal to which you are going to submit. It becomes a pathetic task because just converting to 150 to 200 references or the list of the reference, and it takes almost 1 or 2 days for this simple or what we can say the non-productive task. So to avoid that, there are several tools, that is a Zotero and mainly EndNote, Paperpile, Citavi, RefWorks, JavaFrame, and ReadCube, which you can use for the reference management. What you have to do, you have to just download your all the research articles which you are going to cite. You have to upload these research articles in that particular software, and then you have to give the command or you have to plug it simply to the your Word file, and there will be definitely directly generation of the particular references as per the need or as per the citation style required by the journal. So I guess these are the very what we can say very widely used tools which are being used from so many years by the research community. So I don't think there is, and it will take time also. Let me check. Okay, so we are having again only 10 to 15 minutes, so we have to cover another task also, so we will move forward. Okay, so one more task or one more tools which we are going to see here, that is the citation generators and standardization. These are very beautiful small tools which we can use to generate the citation style. We know that different journals having the different citation styles required. If you are going to publish in the elsewhere, they will require some different site reference formats. If you are going for the ACS, then the RSC, then the YLA, okay, or the themes. So every research publisher, or not even the research publisher, every research journal requires the different citation styles, and these different citation styles, the general different citation styles here I have mentioned, that is the APA, MLA, Chicago, then IEEE, ACS, Harvard. So these are the just examples of some styles. So again, the thing is that if you are having the DOI number of a particular research paper, and if you want to convert that to the reference style, or if you want to mention that paper in the reference list in a specific citation style, then these are the tools which you can help. Okay. So my bib is there, then cite this for me, Scriber, citation machine, Zotero BIB, bib guru, and quillbot also you can use for the for the generation of the citations. Okay, so one of the tool we will see in short. These are very beautiful small tools, and again the free of cost, these are available. Okay, so we will see the Scriber as one of the tool. I have just took one DOI number already here. So if I am having the DOI, this is the interface for the Scriber. So what I can do here, I just have to click here for what reference I need. Just a moment. Okay, so here I have clicked, and what kind of style or what reference style I require. So I will just enter here. So I have already mentioned that you can see that several reference styles are there. You can see the list here. So thousands of journals are available, and these journals require the requirement of their citation style is different. Every journal having the different citation style requirement. So we can simply find it, or we can simply, okay, for example, I will take it here. That is the American Chemical Society I have choose. I can change the settings here. I can change the language. I can change the font and the size of the font and all these things. I will just click on the save changes. Okay. And now I have just copied one DOI number, which I'm going to paste here. Okay. Just I have paste the DOI number I have copied, and I will just click on the site. Very simple. There is no rocket science. So here we can see that there is a title of the research paper which I have just copied. The DOI number. You can also click the title here. You can also give the URL or the keywords. But finding with the keywords again becomes the pathetic here, because you are having the several options of the there is the several research paper generations. So specifically, if I use the DOI number, then there will be only one research paper of the specific one DOI, because I have already mentioned that DOI is the specific number assigned to the research papers, and I will get exactly what I wanted, which research paper I wanted. So this is the research paper. This is actually my research paper, and here we can see, according to the American Chemical Society format, how it is how the citation style has been generated. So if I have to cite this particular paper, I can simply copy this to the clipboard. So this is the citation style already generated, the name of the authors, in the title, then the name of journal, year, and all, whatever the requirement of this particular, I can simply copy this and I can simply paste in the Word document where it is required. Okay. So like this, you can do the several citations by using the DOI or the titles here. Okay. So this is again one of the my personal favorite tool. It is a Scriber. Okay. So you can use any one of them, just like a Scriber or my Beep site for me. Okay. So all are freely available. The one most important thing here we are mentioning, that is the legal paper hunt. As I have mentioned earlier, that is some of the research papers are freely available. These are open access, no issue with that. You can directly go to their website. You can directly go to the what we can say the publisher's site, the journal's website. You can directly download it, read it, use it, no issue. But what if the research papers are subscription based? So you have to pay several rupees for a single research paper. You know that specific publishers like ACS and RSC and Wiley. Okay, so ultimately there is a business of these publishers, so they will not provide you the research paper free of cost. You have to purchase it, or you must having the institutional access again, which the cost for that must be paid by the institutes. Okay. So to tackle this issue, there is one, if the paper is open access, no problem. But if the paper is subscription based, or if you have to pay for that paper, then there is one option, that is the unpay well. I'm not saying that you will get all the research papers which are subscription based by using this tool, but at least you can check it once whether it is available, although your paper is subscription based and it is available somewhere else. Okay, so you can check for it. One of the, what we can say, one of the thing which we are doing from the long time, that is the piracy. And I will not comment more on the pirated papers or the pirated tools, because everyone knows, some of you several times use the pirated sites to get the research papers. But again, the issues with that, you will not get the recent 3 or 4 years papers in those pirated sites. So here there is option of the unpay wall. Okay, so unpay wall, how to use it, and how to tackle this issue of the subscribed papers. So unpay wall is the site here. You have to get the Chrome extension of that particular this tool. Okay, so if you go to their website, that is the unpaywall.org, here you will get the extension. So I will click on the extension, and it is specifically for the Chrome only. You must have used the Chrome and not the other web browser for this. So if I click on it, that is add to Chrome, it will get download as an extension, and actually I have already downloaded and installed as an extension for my Chrome browser. So how it will work? It will directly done, and later when I want a particular paper, okay. So I hope you got my concern. If I am having the research paper which is not freely available and I want it, and not using the pirated sites or the pirated tools, so in that case, how to get it? So the two research papers I have just to save the time, I have copied these links. Okay, these DOIs. Okay, so I will show you. So here one paper is there. This is the ACS paper, we can see here. Okay, American Chemical Society paper. Okay, so as we can see that this paper is subscription based. Here you can see, if you want to read this article, you must have to go to institutional access, or you have to purchase this article. Okay, here we can clearly see that this article is not open access. You have to pay for it if you want to get it. Okay, so but I have already installed unpay wall extension on my Chrome browser. So here whenever I go to any journal homepage or any research paper homepage, there is one symbol you can see here on my right hand side. That is the this is the lock symbol, which is in unlocked condition, and greener, what we can say, in the background. Okay, so as I have installed that, if I have clicked on this, simply I will get the paper here. Okay, so there are some another sources where you can get this paper, and these sources are tackled by the unpay wall. Okay, so if I again clicked on this source and click on the PDF, just okay, so here I will get the whole paper here. Okay, so this is one of the way where you can at least try if it is legally available. So this paper is available, this is subscription based, no issue, but this is legal tool where we can give this the subscription based papers. Okay, so it is seen, means whenever, if I am having this extension, whenever I open any journal site or any research paper site on my web browser, on my Chrome browser specifically, so this symbol will appear here. So it is green, means it is available. It is, although it is subscription based, it is available. If this paper is already open access, then this symbol will appear here with the golden color background. Okay, so if there is the golden color, then you can consider that this paper is already open access and you will directly get it. Okay, and if the paper is not available at all, means although it is the subscription based and no source is available, no another source is also available, then this lock will be in the lock position and the background will be a gray colored. So the color codes we should keep in mind. If the green color is there, then it will be available. If golden color is there, then it is already open access. And if what we consider gray color is there, then it will not be available. So what we can do in this case, if the paper is not available, so there was one option before until November 2025, that is the open access button, where you can try to access such kind of papers which are not even available on the unpay wall. But unfortunately, that option was shut down by by their resource company, and ultimately it is not available right now. So what is the way to get the research papers legally? You can simply request on the research gate. You can go to the research gate, make your profile. Okay, you can log in there and you can ask the research paper there. So people can provide you there on the platforms like ResearchGate. Or the ultimate solution is that if you anyhow want that research paper and you are having no another option and you are at most need it, in that case on that research paper or particularly that paper website, there is mentioned the email addresses of the corresponding authors or the first author. So you can simply request them writing the emails. And I have seen that in my particular research career that most of the researchers helps each other, means they will definitely provide you the research papers and your work can be done. Okay, so so two examples I have taken, one from the ACS and another from the Nature. So I think we will not go for the another example. Okay. Another tool is the graphical abstract, because after completion of the research article, we have to make one good or beautiful graphical abstract which is relevant to our research. And for that, there are several tools available. Adobe Illustrator is there. Then the BioRender is widely used, very popular. Then several new AI based tools are also there. That is the Mindygraph. Canva is widely used for the general purposes. Napkin is also there. PowerPoint we are using from the childhood. So you can use such kind of tools to generate the graphical abstract for the publication of the research papers. So okay, so here is the I'll just show. Okay, a surface for the bio interface for the BioRender. So I will click on the illustration, or I will click on the just a moment. Hello. Madam, can I extend for 5 more minutes, please?
Yes, sir.
Okay, no issue. No? Means, if the time permits, otherwise we will conclude, no issue.
No, you can take 5 minutes.
Okay, okay. For only 5 minutes, I will extend and we will conclude. Okay. No issue.
Yes, sir.
So here, BioRender is one of the tool which we can use to generate the graphical abstracts or the illustrations for the research papers publication. So here, several different categories as far as the science, what we can say the science areas are there. So specifically considering the chemistry, if you have clicked on the chemistry, so you can get several amino acid structures, biochemistry structures. Here we are having the nanoparticles. So we have seen in the good research papers. So it is what we consider the showcase of the particular reputed journal. So and it is having the first impression on the publishers also. So here we can use the several tools here to demonstrate our work for the several means. There are n number of categories, n number of graphical abstracts are available. I'm not going to cover all these things. Just for the sake of understanding, I am showing it as one example. Okay. So BioRender you can also explore. It is again the freemium type of tool. Some of the parts you can use the free access, and for some of the parts you have to pay the money. Okay, so biorender is one of the tool. Okay, so next we are having the profile value, as I have mentioned earlier, that when it comes to the research metric, the profile of the author is a very important aspect because it is visible throughout the world. If you are being searched on the internet, so there are some matrices, there are publications, there are citations, all these things, and it values a lot in your profile. So considering that, there are several what we consider platforms where there is the profile of the researcher. That is the one of the famous platform is the Google Scholar, where everybody must know about the Google Scholar. I will not explain more about it. Then the ResearchGate is also there, and the one most important tool is the ORCID. ORCID is widely accepted by all the publishers. By all the publishers, ORCID is widely accepted, and even most of the publishers have started that if you are not having your ORCID account or the ORCID ID, they will not publish your paper. So how mandatory, how important this ORCID ID is. So generating the ORCID ID is very simple. You just have to go to their website, orchid.org. You have to register yourself by providing the basic information. You can provide your some recent published research papers also, so that it can make your profile on the site, and it is visible. So you will get one unique ORCID ID after registration, and that ID will be widely accepted worldwide to the all publishers. If you have provided just your ORCID ID, you will get, one can get your all research papers data, or whatever the all research profile in a single click. And just I have mentioned that how mandatory it is for nowadays for publishing in the reputed journals. So again, ORCID ID just like your Aadhaar number of the researchers, and just like in India, Aadhaar is mandatory, ORCID is became mandatory for the research point of view. Okay, so there are some another tools which I want to cover. That is the Elicit is AI powered, what we can say, very important and research database. Then the important for the literature survey. Elicit is one of the tool. Consensus is again one of the very beautiful and important tool which serves you while performing all these research related things. Also, there is one important tool, that is the size space. Just in a short, I will give an overlook of the size space. So here is the interface for the size space. You are having the limited credits because it is again the paid kind of tool. So whatever we have seen till now, we have cited, we have seen the citation generators. We have did the literature survey. We have did the auto completes. We have searched the papers. We have extracted the data. We have chat with the PDF. So all these things can be done in one single tool. Here we can see that how can we do with the size space. So again, you can review the literature. You can write the draft. You can search the papers. You can extract the data. You can generate the diagrams also. So very important and very beautiful. And one of the important thing with this particular tool is that you don't have to give even the prompt. Whatever you want to do, you just have to click on that. It will automatically generate a prompt, and you just have to fill the blanks. Means whatever you required. So I just asked him to generate the diagram. So it has already generated the prompt, that is generate a scientific diagram on. So whatever my requirement, that is the I will just CH activation using green chemistry. So if the review article I am writing, okay, and just I will provide simply this prompt, and it will automatically generate it will ask you some questions, some checkings, and then it will automatically generate a very beautiful graphical abstract or very beautiful diagrams for you, and you can directly use those diagrams. Just the thing is that this particular platform is not free to use, not open access, so you have to pay for it if it is required. But some of the credits are there. That is for the new signups, you can use up until 100 credits. And whatever, if your urgent work is there, you can use that 100 credits for using the different Google accounts. So you can get it. So, okay. So this is about site space, and another important thing is that while doing the research, you can set up some alerts on the specific publisher websites, then the Google Scholars. Then automation is the future because several agents are there. If you use any AI tool, so there are agents which do the things on your behalf automatically, and you just have to command once, and the things will get done automatically without your involvement or efforts. So that is the future of the AI right now. So and these tools are means several AI tools are just we can say that launching day by day, and we have to be very updated, not what we can say that being means lagging behind to this specific new generation. So there are again some chemical database tool. I am not going to cover it because ChemDraw is well known to all of you, and some ChemDraw substitutes are there. Some are paid, some are freely available, so you can use it. If ChemDraw is not available, some 3D molecular models tools are also available. That is the JMOL or IQMOL. And as I have mentioned earlier, that the things are changed from a simply notebook to some highly advanced tools. So these are the tools which you can use in the laboratory to maintain all the research data and all these things that were design expert, JMP, Minitab. So you can go and explore these tools also. So I guess the time has been already completed, and thank you so much for listening me carefully and patiently. I hope, I don't know whether it was carefully or not, but at least patiently you have listened to me. So thank you so much for giving me time and opportunity to interact with you all people. Thanks to Dr. Kodape ma'am especially. Thanks to all organizers of this refresher course. And if you are having any question and if time permits, then we can go for it.
Thank you, sir. I have a small question.
Yeah.
Sir, for AI detection, we have in our institute we have Turnitin, but sometimes we don't have any institute access. So free site, which one is reliable? Like QuillBolt is okay, but after some option, some attempt, it will say you have to upgrade. So which other sites are more reliable?
No. I have already mentioned that several AI detection tools are available already. But the problem is that nobody can beat the Turnitin because I have experienced it personally. I have just used or I have experienced so many tools. They will show you some different percentage, different data. But when you actually go to the Turnitin, because you can understand that these tools are freely available in the market, right? You can simply go and access those tools. But for Turnitin, you have to pay lakh of rupees for your institute at least. So there will be difference, and this difference is huge. I have experienced it. So right now means till date, I can't say that there is any tool which we can replace with the Turnitin. In future might be there, so we will be in hunting definitely.
Focus.
Hello. Is I audible, sir? Sir,
Yeah.
I have one question that can AI correctly describe the complex analytical techniques such as FTIR, NMR, like that?
Yes, there are some tools which are specially designed to what we can say to solve these spectroscopic problems. Means there is no issue with that. If some AI developer or the creator have fed all the data regarding to the spectroscopy, so there is I don't think so there is issue of what we can say that generating the data from by providing the graphs and all these things. So actually, I need to search it specifically. Right now, I can't give you exact name, but yes, there are certain tools which I have incorporated. I will tell you definitely.
So again, in that, what is about the utility patent? So I just published one patent, that is the design patent, where we got certificates regarding this design patent. But in case of this utility patent, there should be only the publication in the journal, that is IPR journals.
Okay. So what is your specific question? Is I didn't get it.
That means utility doesn't have a certificate, just like that design patent.
Okay. So actually, the question comes under the IPR, but I will just try to answer it. Whether your type of patent decides the color of that certificate. Even if you go for the design patent, you will get a different color of patent certificate. If you go for the invention or the processes, or if even if you go for the copyrights, you will get a different certificate for that particular task. So certificates are there for everything, but the color is different, and these are the codes for what exact work you have done.
Yes.
Thank you.
Thank you. Thank you. And what is the alternative for Sci-Hub?
For Sci-Hub, yes, I have already mentioned that actually there are certain sites that LibGen is also there, Sci-Hub is also there. But I don't think means whether it is the better platform to discuss about the pirated sites, and whatever the legal solutions are there, or the that I have already mentioned, that unpaywall you can use. Open button was there, very effective and very what we can say the good site was there to get such kind of papers, but it was shut down in the November. So there is no point to discuss over it. But ultimately, if you want any paper, means rigorously, in that case, you can directly demand to that particular author or the corresponding author, or you can demand it on the ResearchGate. People do help, means I have experienced it. People do help. If you appraise, just write in the mail that I continuously cite your paper. Means you just have to appreciate the work of that particular authors, and they will definitely provide you the paper. No issue.
Yes. Thank you.
Yeah, Deval sir.
Yes, sir.
But sometimes we confused SCI and SCIE journals. What is which has the more value?
Which one, sir?
SCI and SCIE.
Okay.
Some journals belong to SCI and SCI, and some journals belong to SCIE. So what is difference? Expanded. That one is expanded. Later one.
Actually, I need to search for that, because we generally go for the Scopus Index journals only. Means whether the journal is Scopus indexed, we only consider that as standard. SC and SCIT, I need to check actually.
Okay, sir. Okay, thank you.
Is there any question? So I think, Deval sir, there are no more questions.
Okay, fine, ma'am.
So I would really like to thank you for giving your precious time and for sharing such a very valuable, important information. May I now request one of the participants to propose vote of thanks?
Good afternoon. Myself, Muhammad Arif, working as Assistant Professor in Government Degree College, Kilam, Kashmir, feels immense pleasure to present the vote of thanks. On the behalf of my fellow participants, I extend my heartfelt gratitude to our esteemed resource person, Dr. Deval S. Deshmukh, for his wonderful, full of knowledge, beautifully crafted presentation, and using thin man technique to make this session interactive. Sir, this session was as interesting as the knockout matches are right now going in the FIFA World Cup. Sir, your valuable knowledge, practical insight, and engaging interaction has greatly enriched our understanding. I thank you, sir, for sharing your expertise with us. My sincere thanks go to the wonderful team of UGC MMTTC, Sant Gade Baba, Amravati University for organizing this refresher course. I pay thanks to the course coordinator, Dr. Manisha Kadape and Dr. Ankit Thakur sir for keeping the decorum of this course. I look forward to more such enlightening refresher courses in the future. Finally, I thank my fellow participants for showing their immense patience by remaining stick to their smart screens for making this program a successful. I wish all of you good luck. God bless you. Thank you.
Thank you so much, Deval Deshmukh sir.
Thank you, ma'am.
Thank you, ma'am.
Okay, participants, our next session is going to be at 3 p.m. Because of some reasons, we are going to start the session at 3 p.m. So all are requested to take the note of this.
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.
Okay,
Noted.
thank you.
Okay.
Okay, ma'am. Thank you very much.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Yes, Dr. Monica ji is there. Dr. Monica Thakur.
Yes, sir.
Yeah, so I think we should start with the session because our next resource person has joined, Professor Prakash Kendre sir. So participant actually, what happened? Professor Goldo sir has some urgent assignment by the ministry. Therefore, he has dropped out his session and we are continuing for the fourth session. So first we will take the consent from our expert, Professor Kendre sir, and then we will start with the session. Hello, Professor Prakash Kendre sir.
Yes, sir.
Sir, very good afternoon, sir. Very good afternoon.
Very good afternoon, sir.
So first of all, we are really thankful to you because you have conducting your sessions earlier rather than scheduled time. So we are really thankful to you, sir. So if you could permit, shall we go with the session, sir?
Within 2 minutes, we'll go for that.
What, sir?
After 2 minutes, we'll start with the
Yeah,
session.
sir. Yeah. Definitely.
Yeah.
So participants, we'll wait for 2 minutes and then we will start with the session. Okay.
Okay, sir.
Yeah, Dr. Monica ma'am, please be stay connected.
Yeah, sure, sir. I am here
Yeah.
only.
Yes, sir. We can start the session. No issue.
Thank you, sir. Thank you. So good afternoon, friends, once again. As I have already told you that we are going for the scenario for conducting the fourth session. And in the fourth session, we have with us a very great and eminent personality from the field of pharmacy, pharmaceutical sciences, Professor Prakash Kendre sir. So first of all, I extend my warm welcome on behalf of the Malvi Mission Teacher Training Center, Sant Garge Baba Amravati University, and all the learned participants, those who have gathered from the across country to this refresher course. And first of all, may I request Dr. Monica ji to please introduce our guest, a brief, and then we will start with the session. Yes, Dr. Monica ma'am, please.
Yeah, thank you, sir. Good afternoon, everyone. I am Monica Thakur, working as assistant professor in the Department of Chemistry at AS College, Khanna, Punjab. So today, on the behalf of organizing team of UGC MMTTC, Sant Garge Baba Amravati University, and all my fellow participants, I extend a warm welcome to our esteemed speaker for the session, Dr. Prakash N. Kendre. who is Vice Principal, Professor and Head, Department of Pharmaceutics, Rajarshi Shahu College of Pharmacy, Buldana. Warm welcome to you, sir. Now I take the privilege to introduce our guest speaker today to all of you. Dr. Prakash has earned his PhD in pharmaceutical sciences and has a teaching experience of 21 years, along with a remarkable research experience of 19 years in the field of nanotechnology-based drug delivery systems. Dr. Prakash has also been granted one Indian patent. He has completed one major as well as one minor research project, along with a phenomenal publication list of 71 research papers to his credit. He has also been awarded Distinguished Professor Award, which was jointly organized by Indian Pharma Education Society and Pharma Tutor and Dominic College of Pharmacy, Philippines, in March 2021. He has also been awarded Best Research Paper Award in 2016. Dr. Prakash's today's topic of discussion is going to be Basics of Nanotechnology in Nano-biomedicines, Types of Nanocarriers, and their significance in drug delivery. So I feel today we are fortunate enough to have Dr. Prakash with us and listen to his invaluable insights on the topic. Once again, a warm welcome to you, sir, on this virtual platform.
Thank you. Thank you so much for a wonderful introduction.
Okay, over to you, sir.
Yes.
Thank you.
Shall I share the screen?
Yes, sir.
Hope it is visible to all of you.
Yes, sir.
Yes, sir.
Okay. Fine. Thank you so much for the wonderful introduction, ma'am. Just confirm me that whether it has been in the presentation mode.
Yes, sir.
Yeah. So once again, thank you so much to the organizer, the UGC Malviya Mission Teacher Training Center, Sant Gargi Baba Amravati University, Honorable Vice Chancellor, and the coordinator, Dr. Manisha Pradap ma'am, on this 2 weeks UGC sponsor refresher course of chemistry. So my session topic, as Dr. Monica has mentioned, that the basics of nanotechnology in nanomedicines, types of nanocarriers, and their significance in the drug delivery. As we know that we should, being a pharmacy people, we should say thanks to the chemistry people, because we have the strong belief that without chemistry, we cannot stand for any medicines or any molecules. Just why this quote is mentioned here, the chemistry transfer the curiosity into innovation and molecules into the solution for the humanity. And I know I'm not expertise in the chemistry, but then just we are trying to use the chemistry for the design and development of this type of various nano-biomedicines. And I'm sure that many of the audience here who have joined the session, definitely they will come to know that, see, this medicine plays a vital role in the humanity for serving the healthcare to the society. So as this slide shows you that the chemistry transforms to nanotechnology, and then it is having some application for the pharmaceutical applications. Now, basically, this chemistry design and synthesize the molecules and materials, and no doubt whatever the methods of the preparation for the nanoparticle itself. So they are basically the chemistry. That is a part of chemistry only. What else we are synthesizing with the same. And this will build up the material into the nanoscale. But the role of the pharmaceutical people is only to shape that molecules in a very convenient form to the patient. And I think this is the major concern when you are talking about the convenience to the patient. And that's why the people from the pharmaceutical, that we are working on that, shaping that molecules into the particular convenient form. And then this will play an important role in the healthcare sector. As this chemistry enables in the design of the material, even synthesis, then many of the polymeric components, because nowadays the novel drug system we are coming across with our pharmaceuticals, novel drug system. And this novel drug system is only on the basis of the new polymeric components, new material which are synthesized by the chemistry people only. without chemistry, we cannot start any kind of work. Even for the drug molecule, the birth is given by the chemistry people. And then this is how it is important for the pharmaceutical purpose. Now, see the material design, then surface functionalization, then just structuring into the nano form in the various type of convenient forms. Then its characterization is also the important part of the discussion for the chemistry people as well as we people too, because without analysis, we cannot identify that whether the formulation has been prepared successfully or not, and their successfully is also depend on how we are going to analyze it. And this is how the very purpose of this chemistry and nanotechnology is only to enhance the solubility of the many of the drug components. We are coming across with many drug molecules. They have the greater potential for the development of the dosage form. Also, they have the greater role in the healthcare system. But the only thing is that due to its certain physico-chemical characteristics, we are unable to choose those components for the development of the formulation. And many of the times, many of the anti-cancer drugs, we can take the example of many anti-cancer drugs, they have the great role in the treatment of the cancer therapy. But more than 90% of the anti-cancer drugs, which are not soluble in water, they have many issues concerned with your development of the formulation. And I think this is very important for the nanotechnology has given the flexibility to us, how we can enhance the solubility of these drug molecules, and thereby then we can utilize those molecules for the development of the various targeted drug delivery system in the treatment of the cancer. So improving the solubility is the major, what we can say, the application of this nanotechnology. Then enhancing the viability. No doubt, if you are enhancing the solubility, the viability will automatically will get increased. And more particularly, the application of this nanotechnology is in the targeted drug delivery. Because cancer treatment, the cancers, various type of cancers are existed in the body. And to treat those cancers into the particular region of the body is a very difficult task for the therapy. And many of the times, whatever the drug we are taking in the form of formulation, it is unnecessarily get released to the other body part or other body region. And we know that these drug molecules have the therapeutic benefit, no doubt, but they are also having some side effects and sometimes the toxic effects also. And then this is the major, you can say, the hurdle in the development of many of the pharmaceutical products. And then we need to just focus on the particular area where the drug is actually required. Then for that purpose, this nanotechnology plays an important role to design and develop the targeted drug delivery, where these drugs in the form of that particular nano size will reach to the specific site of the body where the problem is exist, and it will get treated. So there are many advantages why we are using this targeted. Thereby we can have the greater utilization of the drug, no doubt. Then there are many other side effects which are available, which are due to the unnecessary distribution of the drug in the body will get avoided. And that is playing a vital role in the chemistry, in the cancer treatment. And that is the major breakthrough in the cancer treatment as a nanotechnology. Then some of the control and sustainable formulation is also possible. Just we can make some nanostructure which will provide a precise release for the longer time, because there are many diseases are there, just like chronic diseases. We can say the hypertension, then diabetes, then cancer, and many more such kind of CNS disorders. That is what some of the heart diseases. So where we require the continuous release of the drug from the drug delivery device. And I think that is only possible to release the drug of this to the site of action for the longer period of time, only because of some of the polymeric component that we are using as the drug release retardant materials. And I think this is sure that these kind of polymeric components are only be synthesized with the help of the chemistry. And we know that the polymeric sciences is a special branch of the science that deals with the development of various type of polymeric components, and chemistry is playing the important role in the design and development of this polymeric component. So here we will today have some sort of information about this nanotechnology, how it is important as far as this nano-biomedicine is concerned, and which chemistry part is involved in that, and which type of reactions we are going to utilize. Because after all, whatever the synthesis of the nanoparticle is there, that is only with the help of some of the chemical reactions, and none other than that. And that is how it is related with this. And that's why I've chosen this topic for this refresher course of the chemistry, so that I can at least correlate the pharmacy with the chemistry, and then we can also think together to work collaboratively how chemistry can help us to make a different type of novel drug delivery system for the human healthcare sector. Now we will understand that how this nanotechnology is used in the drug delivery. then how the medicines are prepared. Then we'll also see that what are the latest advancement in the innovations in the nanotechnology, which type of nanocarriers and smart materials. And even though AI-driven drug release profiles are also possible, that can be also we can incorporate because the AI is nowadays this is playing very important role in every industry, and see why not then these pharmaceuticals and chemistry is also not far, you can say far from this AI. So everywhere there will be the AI applications. So we'll also discuss some real-time applications in the cancer treatment, in the neurological disorders, some of the vaccines. We'll take some examples, some of the marketed formulations, how they are prepared and how they are working. Then we'll also see that what are the future challenges in the development of this nanotechnology, just like biocompatibility and regulatory concerns. Why it is important? Because we are synthesizing the nanoparticles using the chemistry and various type of techniques and advanced technology, and designing and synthesizing the nanomaterials. But the major concern is the regulatory, because being a nanoform, one should also understand what is the safety concern of that particular molecules that we are converting into the nano size. And that's why the regulatory authorities are playing very important role in this type of selection of the materials, and thereby they can utilize and finalize by the FDA, given the approval for that, and then only you can utilize for the development of the nanomedicines and biomedicines. So we'll just see what we can go for. Now, before going to start with some of the other techniques and other kind of applications of this nanotechnology, we'll understand some terminologies which are used in this nanotechnology. What is the definition? So definition of this nanotechnology, so it is the science and engineering of manipulating the material at nanoscale. So nanoscale, now we can talk about this nanoscale. There is a huge range of the nanoparticles we can synthesize. But typically when you are saying the nanoparticles or nanotechnology, one can have the particular size range of the particles that are being synthesized, and that is from 1 nanometer to 100 nanometers. Somewhere you will also find that the definition will say that from the nanoscale of 1 nanometer to 200 also, no doubt that they are also in the same category of nano size range only. But only the thing is that how we are making that nanoparticles, synthesizing the nanoparticles, it will depend on that what size you are getting. And it will also depend on what applications you have, what is the end utilization of that particular nano-sized particles. So that will also have the impact on the development of these nano particles. Now we'll also understand what is nanoscale, and then what are their physical and chemical and biological properties. Because we are dealing with the pharmaceutical product development and their role in the biomedicine, so one should also very sure about what are the biological properties of these nanoparticles. Then we'll also have some sort of other kind of properties, whether they will have the suitability in the development of the drug delivery, some of the diagnostic devices, and many other therapies in the medicine. So because size matters a lot in this case, because it is depend on that particular size range, how it is targeting to the particular region of the body, because body is made up of with the help of the various cellular components. And to deliver particular to the site of action to the targeted region in the molecular region at the molecular levels, we need to deal with the size of the nanoparticles. All nanoparticles will not reach to the particular site to the region of the body, because there is some restriction in the transport mechanism of the drug materials. So depending on that size range and molecular weight of the components, they are only get delivered to the site of action. So one should very clear about whether we are going to make this formulation is targeting to the particular site where how much amount of molecular weight size is only, you can say, the suitable to deliver the drug into the region. Then we will also see that which kind of properties has been enhanced once we are converting these material into the nanoform. Definitely when you are converting these nanomaterials, so it will get converted into the nano size, and thereby it will increase the surface area. Even though there are other properties, just like their reactivity will also get improved. And maybe sometimes the stability is the major concern when we are converting this material into the nano size, because we know, so nano size is always unstable form of the preparation. Let us take the example of now this rainy season. We have the sugar cubes. The sugar is present in some cubical form, so it is not having issue of the stability. It will not get converted into the, I can say, the agglomeration of that sugar particles. But when you are just reducing the size of that sugar cubes in the form of powder, so the stability will get affected. They will be in the state of unstable, and maybe there are chances that they will get agglomerated and the stability will get improved. So those properties are also important while design and development of the nanomedicine that we should take into consideration. And based on that, we can select the method of preparation and then the preparation of the drug delivery successfully. Then we'll see that there are applications. Now, this nanotechnology is not having the restriction to use in the pharmaceuticals only, but it is also used in electronics, energy, environmental science, and everywhere we can find the application of the nanotechnology nowadays. And this is major breakthrough of nanotechnology, how it is used in the field of pharmaceuticals with the greater therapy and imaging, diagnostic purpose, and even nowadays the concept of personalized and customized medicine. Now, because now later on we'll see what is customized medicine, what is personalized medicine, but now see, we'll have some other terminologies which are related with this macro, micro, and nano. So let us take the example. So what is the macro scale, what is micro scale, and then nano scale. And definitely this size range will give our idea which kind of material can be incorporated in which drug delivery system and which drug delivery system can be utilized in which part of the body. So definitely we'll get the idea from this nanostructure, microstructure, and macrostructure. So this macrostructure, a human being, smartphone, sheet of paper, and table, and so many examples you can take. So they will be in the range of the from few mm to the meter. So that is what it is visible in you can say visible to the naked eyes, and you can see that very immediately when you are observing that objects. But in micro scale, it falls into 1 millimeter to 1 micrometer. So just the examples of red blood cells, some of the bacteria which are not easily been visible by the naked eyes, but then we need some microscopic examination, and thereby we can just make the resolution of that, and we can find it whether it is be small size or what. And nanoscale. Now it is as good as it is very difficult even with normal microscopic examinations, because normal microscope will also not be, you can say, suitable for visualizing these nanomaterials. So you can see the example of DNA and DNA strand, it is less than 2 nanometer size. And even some of the examples of viruses, they are also in the nano size. You know that the COVID virus, we know very well that it was very difficult to manage with this type of nano form of the materials. And then we need highly sophisticated microscopic, just like scanning electron microscope, that is what the transmission electron microscopic examination. And then thereby only we can understand the size and even some of the physical, chemical, and biological properties of those materials when you are converting to the nano form. Now, this is how the comparative chart that I have given you, the same kind of thing that we discussed. Now, what are the key applications of this type of nano materials in the development of formulation? So definitely the drug delivery system. So nanocarriers, why this definition of the nanocarriers is here? Nano means nano size, and carriers means this nano size material is going to carry the drug at a molecular level to the various parts of the body, and then it will be treated as a targeted drug system. Some of the examples, maybe these are some of the you can say the terms are new to you, just like liposomes, polymeric nanoparticles. So later on we'll see that what are the liposomes means and how it is made up of and which kind of material is utilized in the development of this liposome. Even though the polymeric nanoparticles are the major area of pharmaceutical product development, where we are using the variety of the polymers which are using for the synthesis of the nanoparticles successfully. Then this is how I repeated again, the cancer treatment is the major area of pharmaceuticals for using these nanomaterials and to deliver the drug to the special sites of the action. Then medical imaging, the diagnostic, MRI, and various diagnostic devices are there where we need to use this nano form of the material for the imaging the disease conditions which are there in the body to detect it at the certain level. It is not possible by other way that we can just visualize it, but with the help of this nanotechnology, one can visualize that particular disease condition at a molecular level in the body, and then the diagnostic area also we can utilize this nanomaterial. Now, regenerative medicines are also there. That is a concern. That is what the part of the biotechnology where the tissue engineering is playing an important role and various applications in the wound healing purpose. Later on, I will also tell you that one of my PhD scholar from the same university, Sant Garge Baba Amravati University, he has won the first prize in the Avishkar competition and state level competition, as well as national level competition and international level competition of the animation recently happened in the Himachal Pradesh. Then nanorobotics, because see, the technology is always playing the role everywhere. And this is how that nanorobotic form of the preparations are also utilized for the precision drug transport and various surgeries, which are very critical in, you can say, doing by the surgeons. So this nanorobotics will play an important role and helping us to make it very precisely that surgery and the drug transport, whether it has been reached to the site of action or not. So then this is how there are some of the advancements in the technology to just minimize the, you can say, the toxic effects and make the life of the patient and life of the, you can say, the people very, what we can say, carefully to utilize those materials. Now defining the nanomaterials. So nano-biomedicine is the definitely a special term for us because we are going to use the interdisciplinary approach for making this nano-biomedicine. So here is the combination of nanotechnology, biology, and then medicine. And together with, then we are able to prepare the nano-biomedicine. So this is definitely a great chance to we people to work interdisciplinary and collaboratively to develop such kind of nano-medicine or nano-biomedicine. And that will be, I think, very important aspect as far as NAP is concerned, because now they have mentioned that how we can interdisciplinary work together and we can generate the new medicines to the people. So this nano-biomedicine represents a convergence of the nanotechnology, biomedicine, offering the unprecedented opportunities for the revolutionary healthcare, and definitely we are going to use it. So there is one concept in 1959, the Feynman's vision, and he has first time investigated the nano form of the, you can say, the particles or materials. I have just taken it from the AI only. That is now we are also going to use, because in our syllabus also there are many changes has been happened due to this NAP, and they have incorporated many AI tools and technology in Python language and many more things. So we are started to use of this AI technology. Now see what, there's plenty of room at the bottom. So this is how the very first concept has been mentioned by the Feynman's vision, where it has been then replicated in the various form and then later has been investigated and termed as a nanotechnology in 1974 by this Noyo, one of the scientists. Thereafter, then development has been started as various tools has been introduced by the many of the scientists, and it was easy to understand that whether that particles are in the nano size or micro size with the help of the some of the microscopic examination, just like atomic force microscope, this in 1980s. And now in the 21st century, now we are not far from this kind of tools and technology, where we are using it in the development of the nanobiomedicines. So see, this is how the various applications of the nanobiotechnology in the medicine. So electronics, computing, no doubt, then the aerospace, automotive, consumer products and textiles, agriculture, food industry, and whatnot. So everywhere it is utilized. And then definitely we're also using this nanotechnology for the biomedicine synthesis. Now, there are the different type of key benefits of this nano technology. So as I mentioned in the very first slide, targeted drug delivery system, then control and sustain drug delivery system to improve the bioavailability, then crossing the biological barriers where the drug otherwise cannot be reached. You can take the example of the blood-brain barrier, where many of the drug molecules, due to their high molecular weight and their nature, they are not crossing that BBB, that is blood-brain barrier. So this is the easy way to convert those materials into nanoform, and we can have the special and suitable drug route of administration, just like nose to brain delivery, and where these barriers of the blood barrier has been get avoided, and then thereby we can utilize these nanomedicines. So personalized medicine, okay, fine. Now if you'll see that importance of this nanotechnology in the improvement of this pharmaceutical product. So it is having the role of 40% of this nanotechnology that we are using this approach for the improving the bioavailability of the drug, because as earlier I mentioned that many of the drugs are having greater potential in treating the many diseases and disorders, but only the concern is that they are not water soluble and their bioavailability is very less. So with the help of this nano form of the preparation and the drug, we can able to enhance the bioavailability, and we are using it. And that's why I'm telling you this, we are using this technology for the enhancement of the bioavailability. Then why it is again important? Because it will reduce the toxicity by 60%. So being in nano form, as mentioned, they are only delivered to the site of action, and unnecessarily it will not get delivered to the other body region. So definitely the toxicity related issues will get avoided, and better and greater utilization of the drug will be there at the site of action where actually it is needed. So then thereby we can enhance its efficacy by 2x, or many times the 3x and 4x also we can have the efficacy because of the proper utilization and the proper site of action. Now, understand the concept of targeted drug delivery. Why I am just forcing on this targeted drug delivery? Because the nanotechnology is playing the important role only in the design and development of targeted drug deliveries. And that's why these nanoparticles can be engineered by using some of the sort of polymeric components, some of the other naturally available resources of the polymeric components, and then we can able to prepare this in the form of novel form of the drug formulation, and that can be definitely overcome the challenges which are associated with the traditional chemotherapy, which otherwise damages the normal cells, and that's why it is having the greater role into the targeted drug system. So what sort of advantage we are getting together with this nanotechnology in the development of this targeted drug system? One is the precision, because precisely we are going to deliver to the site of action where the diseases occurs, and minimizing the off-target effects where otherwise it will create the issues and side effects to the other off-target in the body. Then protection. So it will protect the drug from the degradation in the body. Let us have the example of some of the examples we can take. Just like when you are taking this formulation by the oral route, so definitely, in the drug will goes into the stomach first, and in stomach there is acidic media, and this acidic media will degrade the drug. Now here the chemistry is very important, because once the drug will get degraded, so maybe it will get converted into the various metabolite form, and we know that, and we are not sure about whatever the byproducts are formed. But now here is the chemical reactions are happening, that is called as biochemical reactions, and due to this biochemical reaction, it will get converted into the various toxic products or byproducts, which will otherwise affect the body, and there will be that very issues of the body that maybe the consequences maybe to the death of the patient will be there. And efficacy is the major concern. Many of you we are developing any pharmaceutical product. Efficacy means, this meaning of the efficacy is the effectiveness of that drug delivery system. Whatever the drug delivery system you have prepared, I think the effectiveness is very important. So when it is delivered to the site of action, then how it starts, onset of action, and then duration of action, and how long it will create the impact and effect on the body for treating the diseases. And I think this is one can achieve with the help of the nanotechnology only. And that's why I am telling you, these are the, you can say, the major advantage of the use of the nanotechnology for making the nanobiomedicine in the targeted form as a precision, protection, and efficacy. Now, as earlier, as just now mentioned in some of the slides, that liposomes. Now here we can see what mean by the liposome. Now lipo means the lipid component, and somes means it is resembling that the lysosomes which are there in the body in the cellular level, and somes means very small size. So lipo means lipid, somes means very small size. As good as we know that this is the part of your biological cells, and such a small molecules and such a nano form of the material if you are using and preferring with the help of the lipid components, so that will be feasible for making the nanobiomedicine. Now, there is again one question which is arises in your mind: why lipids can be utilized, and what are the advantages of these lipids when you are using in the form of drug delivery system? So, as we know, we learn into the 12th science even, and maybe you are more familiar with this as a science graduates, and many of the people we are working as an assistant professor and professor, that biological membrane is made up of lipids as well as the hydrophilic polar head groups. And I think for the transdermal delivery, the lipid form of the material is most important for the permeation to the transdermal region to the skin. And that's why this lipid material will play important role in the delivery of the drug across the biological cell membrane, where the lipid bilayers are present across the biological membrane. And that's why one more advantage will be added, because the use of the lipid will be considered as a part of the body, as a part of the cell, and there will be less chances of the toxicity. Otherwise, if you are using the other synthetic components in the design of the drug delivery system. There is some advanced version of this lipid that is for solid lipid nanoparticles. Generally, we are saying that's SLNs. So it is nothing but a mixture of solid and liquid lipids offering the higher drug loading. The drug is entrapped within the bilayers of this lipid membrane, and that is even in the nanoscale and nano size. Now, then it is very important part as a delivery product for the molecules across the biological cell membrane, which will act as the ideal form for the hydrophobic molecules to be get absorbed at the biological membrane. And one more advanced form of this lipid carrier is the nanostructured lipid carriers. Now, this is again somewhat little changes there apart from the liposomes and SLN. So it is a blend of solid and liquid lipids, enhancing the drug loading and preventing the expulsion of that drug molecules from the lipid bilayers. And where it is mostly utilized in the development of the biotechnologically developed product, just like vaccines, mRNA vaccines, and some of the chemotherapeutic agents, where it will deliver the drug to the particular site without any side effects and effectively to the particular site, reducing the side effects using this. Now, see, this is visible. Am I audible and visible? This slide is visible, all the audience?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes,
Now
sir.
look at
Yes,
this
sir.
liposomal structure. Now it will be just like it resembles with the biological cell membrane. Now, if you remember the structure and cross section of the biological cell membrane, you will find the same kind of structure. And as a drug delivery device, we are going to use the nano form of the material, and that is we are designing in a fashion that it is showing this hydrophobic bilayer and definitely hydrophilic core layer. The meaning of the same is the aqueous form of the drug is entrapped within the lipid bilayers. Now see, the drug is present in the aqueous form, which resembles with this hydrophilic core, and then the lipid bilayer is resembling the part of your biological lipid bilayer that is the made up of the cholesterol and some of the phospholipids. That same we are going to utilize, and that we are converting it to nanosite. Now see what sort of advantage we are getting here. One thing is that the preparation you have made is having the same kind of structural features just like a biological membrane is having. Then second thing is that now it is available in the very nano size. So molecularly at every level into the body, we can just deliver the drug easily. And in most of the cases in treating the cancer disorders and diseases, where the drug is required to be released at the molecular level, and thereby we can also avoid the unnecessary utilization of this nanoparticulate drug material to the other body region, because some of the chemotherapeutic agents are very harmful to the body. They are also killing the normal biological cells, and then it is very necessary that the drug has to be reached to the site of action where the cancer exists. And see, then we have some size range of this lipid component into the nanoform, and based on that size, we have some of the terminologies that converted into the structural features, just unilaminar, then small unilaminar having the size units of the 20 to 100 nanometer, then medium unilaminar, that is what MU is, then large unilaminar having the more than 100 nanometer, giant unilaminar having the 1 micron or greater than 1 micron. Then multilaminar. Now unilaminar, there is only single bilayer of the lipid component material is used. Then in multilaminar, we are using the you can say the various bilayers of the lipid component. So it is called as multilaminar. Now one advantage we are getting here in the multilaminar. So every layer we can load the drug inside. Suppose now first layer is formed and then second layer is going to form. So what we can do, we can entrap the drug. We can load the aqueous drug in every layer. Now what is the advantage of this? Using the multi-layer, we can able to load the drug in large amount, because in many of the cases, we need the dose to be adjusted. And this might be becomes a limitation in some cases where the dose of the drug will be higher. In those cases, to entrap the drug into the unilaminar vesicles is not it is a difficult task. And that's why we can opt for the multilaminar where we can load the drug at every layer, one layer above the another layer, and thereby we can load the drug at maximum amount and drug dose can be fulfilled. Just like oligolaminar having the more than 3 layers and multilaminar vesicles having the size. Now look at this, how the laminarity will be increased. and with the laminarity, increasing the laminarity, the size has been increased because layers are increasing surrounding to that. So that is possible, but that is having the application that we can decide. The formulator will decide this, what is the utilization of this, whether we need to deliver in small fraction from the every layer as a sustained layer or control release form. So based on that, we can select the structural features for making this nanoparticle in the form of liposomal structure. Now, another advancement in the development of these lipid nanomaterials or lipid nano structures is that now if it is visible to you, look at this and we can see how we are engineering it at various layers. Just look at it. We are engineering this structural liposomal structure, you can say here, just adding some other components and materials to make it smarter. Now, what is means by smart drug delivery? Let us have the one example that we can discuss. Now, everyone knows what is cancer. Cancer is nothing but the abnormal growth of the cells and tissues, you know very well, and where the growth of the cells will be higher, and thereby maybe the chances are there it will get widespread in the body and cancer will get spread throughout the body. Now, one of the scientific study has mentioned that these cancer cells have the affinity for the folic acid molecule. Now see how we can make the smarter drug delivery system. This nano form of the formulation, and we are using some of the other component to add here on the surface of this liposomal component. And this folic acid, it has been observed that it is having the greater affinity for the cancer cells. What we can do, we can just add this folic acid on the surface of this liposomal component, and this will take this liposomal nanostructure to the site of action where that cancer cells are exist. Because we know that the folic acid is having the affinity for the cancer cells, and thereby we can utilize this smart drug delivery. Now, this has been used in the development of some of the biotechnological products, just like genetic material, DNA, RNA, and that also we can provide with the help of this. You may heard about the monoclonal antibodies. So that is also biotechnologically developed product. So these monoclonal antibodies also we can add some of the antigenic components, especially to synthesize the or generate antibodies against these antigens which you are going to add here to these nanostructures, and thereby then specificity is utilized. Because in the particular region, there is a affinity for the particular antibodies, because these antigens as a foreign material which are there present in the body in case of infection is having the affinity for the specific antibody. And those antibodies also we can add here to these nanoparticles, which will get directed to the site where it is having the affinity toward that antigens. So this antigen antibody specificity is also used as a smart way to deliver the drug. Apart from that, we can utilize some of the carbohydrate moieties, some of the pegylated material, that is what polyethylene glycol materials, peptides, aptamers, and then proteinous components, some of the ligands that we can utilize and what not. So this is how we can make the smart drug delivery system with the help of these liposomal structures. Now, what is meant by solid lipid nanoparticle? Look at this. What is the change in the structure? So this is, in previous case, we observed that aqueous drug is surrounded by the hydrophobic lipid bilayer. Now here in this case, solid lipid, now in the form of drug, is surrounded by the surfactant layer, and then you are going to make it the solid lipid nanoparticles. And it is size range is 50 to 1000 nanometer, no doubt. Now, this is also depend on what sort of drug delivery system that we need to prepare for treating particular diseases and disorders that we can make. Now, nanostructured lipid carriers. Now, see, here we are using the aqueous drug core material as a phase, then liquid lipid also we are utilizing, some solid lipid also we are utilizing, drug molecule also we are utilizing, and surfactant system also we are utilizing. So all the components are having the special role in the delivery of the drug and targeting to the special site of the action. And this is how those material combinedly utilized, which will become a nanostructured lipid carrier, and that can be utilized for the delivering the drug. Now, very important part of this discussion today, the polymeric nanoparticles or polymer-based nanoparticles. Now, why? Because this polymers has given us flexibility, as earlier I mentioned that the special science of the chemistry or branch of science, that is polymeric science, is working continuously. The scientists are engaged with synthesizing many components or polymeric components regular basis, and that we are finding the application of this polymer starting from the morning itself to the bed, because we are using a lot of polymer components in our daily life. So what are plastics that we are using are nothing but the polymeric components. Now we can look at various type of things that we are using. So spec we are using, mobile phone, cell phone we are using, watches we are using, and whatnot we are using the components. Even in the construction we are utilizing some of the polymer components. So the polymers are playing an important role in our today's date, and definitely these polymers are also playing the important role in the design and development of nano-biomedicines and nanocarriers. And because they are available in the ample amount and they can be synthesized at the large scale by the chemistry people, their applications are wide. And we are too also very happy to get such kind of smart polymeric components in the design and development of the various novel drug delivery systems. And I think we should again say thanks, because of this polymeric science, we are able to prepare and do the research in the development of various drug delivery systems. Now, these polymeric nanoparticles, just like solid colloidal particles made from the polymers, offering the various you can say type of drug releases, which are controlled, delayed, time release, prolonged release, and even targeted release. Now, the dendrimers, they are also playing the important role. Now, let us understand what are the dendrimers. Maybe many of the people are aware of this dendrimer. What are they? So these are the branch tree-like polymers. Now, what they resembles again, just like the liposome that we prepared, the resembles with the normal biological cell membrane, just like that. Dendrons which are present in our body, so they are also in nano size. At very molecular level, they are in size. And this dendrimers, with the help of this polymeric science, so we can able to prepare this branch-like dendron-like structures, where the drug can be incorporated and encapsulated and utilized in targeting to the disease condition. More specifically, in case of the CNS disorder, central nervous disorder. Now see how chemistry is working. Now the chemistry is looking at the body, anatomy and physiology, what exactly the body is made up of, how it is made up of, what are the biochemicals and environment is present in the body. They are considering these environments, they are considering this anatomy and physiology, and now they are synthesizing these kind of polymeric components. They have the similar structures or affinity or otherwise having the suitability and biocompatibility. So these features they are adding into the materials, and now we people are using these smart materials to make these drug delivery system to serve the healthcare to the society. Now the micelles form of the preparation is also there. Now this is also the same kind of thing, that just like a chemistry that we are using it and chemical reactions we are using it. Self-assembling spherical structure formed by amphiphilic polymers. Now you need to, this, what is meant by amphipathic molecule or amphiphilic molecule. Amphiphilic molecules, it is having the both characteristics of hydrophilicity and lipophilicity. And as we know that the cell structure is also made up of the same kind of feature, that is lipid bilayers and polar head groups. That is what aqueous head groups. That's it. And the same kind of molecules we are synthesizing so that the drug permeability will be more, because we are just making similar like cell structure. And these amphipathic and these amphiphilic polymers are then of prime importance in the development of this kind of drug delivery system, which are not even only delivering the drug in the ample amount, but also stabilizing the formulation in vivo, in body, because the biocompatibility is the major factor. So once that drug delivery system enters into the body, it should survive same as like when we are prepared outside the body. And that in vivo survival is very important. And in vivo stability of the molecule and this kind of nanoparticles is very important. And I think this is the major, we can say, the hurdle in the development of nanotechnologically developed products in the pharmaceutical, the in vivo survival and stability of this nanoparticle. Later on, we'll see what are the things that we need to consider while development of this as a regulatory point of view and as a, we can say, the health safety concern of the this pharmaceutical product. Now, these polymer-based nanoparticular or nanocarriers are having the tunable properties, enabling that customized form of the delivery. As like I mentioned you, they can be molded and designed in a different way, and it can be utilized in different type of treatments. And the biocompatibility and biodegradability is also having the more concern why you are using these polymeric components and having the wide application in the nano-biomedicines. Now see, 1 or 2, 3 examples we'll see how these polymeric nanoparticles are prepared. Now see, this is same like just like reaction that we are doing. Now look at this polymer plus drug we are taking together. Then nano formulation by various methods, that there are a lot of methods that we are going to utilize. And how it will get converted. So either it is in the nano capsule form. Nano capsule means what? The drug molecules, the drug particles, nanoparticles are covered with the polymeric components. And then it will covered with that. So it is called a nano capsule. And nanospheres means it may be the matrix system. How the drug and polymer together we utilize as a matrix system, and we convert it into the nano form of the particles. So it converts into the nanospheres. Then drug will get entrapped, then surface adsorption will be takes place, and thereby we can utilize it. So the surface adsorption is very important because we are making it more functionalized while delivery into the body. Because functionalization of this nanoparticle is very important once you are prepared. Otherwise, then it is useless, because the functionalization is important because we are going to activate them once they will enter into the body, once they will administer into the body. So their activation is very important. And there are nowadays very smart drug systems are also there. So we are going to utilize the body's environment. I can tell you the example of that: pH sensitive or pH activated drug system, hydrodynamic pressure activated drug system, then osmotic pressure activated drug delivery system, then magnetically activated drug delivery system, and so many other kind of enzyme activated drug system, and maybe feedback regulated drug system, where there will be the biological reaction in the body, and due to the reactions into the body with the biochemicals which are present in the body, then there is activation of the drug. Now, this is not a part of discussion for this because it will be in the very depth for the chemistry people to understand. But these activation is very important as far as this drug delivery or nano drug delivery systems are concerned. Now, see, as I earlier mentioned that the dendrimers, how it is made up of. Now, look at this. One structure you can observe here, just like a dendron. See, this is how Y-shaped it is visible to. Hello.
Sir, yes.
Yeah.
Yes,
So
sir.
you can just, yes, you can just look at this Y shape.
Yes.
This is all. Now all this structure is just like dendron, and it is coming together. And how you are making this dendrimal nano form of the preparation. At the right side corner, it is assembled into the structure that is nano size, and that is only assembled an assembly of what? Assembly of this dendron type structure. And what are the dendrons are and dendrimers are? So these are the branch like polymeric components only. Now what we can do here, we can load the drug induce these dendron size, nano size particles, and we can make a sphere, nanosphere, which is available or ready for delivering to the body part where it will reach. How it will reach? Because where the dendron will reach, just like that, the drug loaded dendrimal drug delivery system will also reach to the site of action. So more specifically, it is used in the central nervous system disorders. Now micelles. Now here again, see, we will find the same kind of structural feature as like your biological sameness. Now here the role of the surfactant is very important in this case. Now the micelles is a spherical structure that forms and by the aggregation of surfactant molecules. Now we know the definition. I think there is no need to define what we mean by surfactant, what we mean by the HLB scale, where that surfactants fall on which scale it is having the size range of that particular and all kind of thing. So surfactant is nothing but these are the kind of material. They are highly surface active, and I think they are very crucial and important in the design and development of many of the healthcare medicine because they are playing the important role in the activation of the drug delivery system. Or otherwise, they are playing important role to reach to the site of action because of their surface activity. So in water, the hydrophobic tails face inward and the hydrophilic heads are face outward, which are shown here. And then we can make the drug system which are in the micellar form. And that is definitely along with the drug. We are loading the drug inside particular. Now metals are also not far from this nanotechnology and role of this metallic materials in the design and development of nano-biomedicine. Not only metallic, but even inorganic nanocarriers are also utilizing the design and development of this nano-biomedicine. I think this is a great discussion because the chemistry people are here and we the people where we are having the role in the design and development of the various drug delivery system. But one alone cannot do this. And without the involvement and engagement and collaboration of you people, it is not possible. Now you are getting the idea which type of materials nowadays we are using for the design and development of this nanobiomedicine. And definitely I know that this presentation will be very helpful to you people, because after all, whatever we are going to synthesize at the lab as a part of chemistry, doing the lot of chemical reactions and so many, you can say, schemes we are running. But then what is the outcome of that particular compound that we are going to synthesize? What are the benefit to the society? How we can utilize in different area? And this pharmaceutical and healthcare area is also one of the, you can say, the thirst area where the chemistry people can come together. They can synthesize the new molecules. I'm very happy to share with you all that recently I am working with IIT, IIM, and then even ICER people. So they have approached me to develop some nanotechnologically engineered product for the purpose of that the component they have synthesized. So from the Bangalore, then Calcutta, and even from the Delhi, these people are together working and taking the help of me for the development of this nano delivery. And definitely they are saying that, they are claiming that whatever the component they have synthesized, molecule they have synthesized, it is having some activity and role in the CNS disorders and targeting to the brain. Now only the challenge to them is how to prepare the nano form of the medicine and then how we can evaluate it. And that is why they are working with me, because they are playing the part of that chemistry. And then even ICER organization is playing the role of the preclinical trials. And me as a formulator, as a part of this, going to prepare some nano formulations on that. So I am just appealing you people come together. And if you have such kind of molecules of greater potential in the healthcare sector, definitely we can shape it in the various novel form in creating the nano-biomedicine. So now these metals, and I am again exploring how these metals and inorganic nanocarriers can be utilized in the design and development of this nano-biomedicine. So see the gold nanoparticles. Many of you people are aware about the Swarna Bhashma. Is it? You heard about this Swarna Bhashma?
Yes,
That is
sir.
the Ayurvedic concept, the people they are using. Just participate and discuss with me. Otherwise, I am just starting with the same discussion and nobody is there, so we'll create the problem. So, Swarna Bhashma that we are using, and that is in the form of small particles. Do you know what is the homemade concept for this Swarna Bhashma? And this Swarna Prashan, Swarna Prashan in that case. So the pregnant lady, they are giving this kind of Swarna Prashan. And even to the newly born baby, they are giving this Swarna Prashan. When the lady is pregnant, that during that days, now as a homemade remedy, you can say the tradition. So the remedy, you can say, the pure gold, we are just heating it with 2 cups of water, and it is boiling to the extent where that 2 cup water will be remain as a 1 cup of water after evaporation. What happened during this? Now the pure gold material you have utilized, we have heated in 2 cup of water. We have completely evaporated 1 cup, and then 1 cup is remaining. So there is a nano formation of that. Nano particles will come out from that nano material that we have used. Many of the people, they are using that rings, gold rings and pure gold for making this. And that water now, after cooling, it is given to the pregnant lady. Now, you know what is the role of these gold nanoparticles? So gold is utilized for the purpose of boosting the immunity, then good memory, and many other kind of, you can say, the benefits to the body. In one word, you can say the immunity booster. So that is enough, I think so. And for that purpose, now then that may be the some crude form of that thing we are doing at home, but then gold nanoparticles also we can synthesize. Now, what is the Swarna Bhashma is nothing but, now scientifically it is proved that Swarna Bhashma is nothing but the gold nanoparticles. And these nanoparticles, gold nanoparticles, we are using for delivering the many of the drug And this, along with this gold nanoparticle, even as such, gold nanoparticles can be utilized for treating many skin disorders and even though some of the central nervous system disorders. Just like I mentioned, the memory booster. So maybe there are certain conditions in the brain where these gold nanoparticles play a vital role in treating the diseases. One more thing, I think that is again chemistry part, I will tell you. The carbon black, it is there on the lamp, in the ancient days and in the traditionally it is being used by the many of the people, ancient people. They are using the lamp, that carbon black, isolated it, and we are adding some Shuddha ghee, that is what cow ghee we can utilize in that particular, and some other component, and we are making kajal, to incorporate into the eyes. So that time, our ancient people and they are not aware about that is in the nano form. Now it is scientifically proved that whatever the carbon black from the lamp which is there, so it is having nanoparticles, and that is the carbon nanoparticles. And that's such a fine form of the preparation we are utilizing as a kajal along with the cow ghee, that making it. So that time also the nanotechnology was existed. And this is how advanced way we can utilize it. That is only the case with the help of the chemistry people and we people here that as a pharmaceutical. One more example I can tell. So nowadays we are saying that nose to brain delivery, because we know that some of the drug, when they are taken by oral route, they will not get delivered to the brain because the blood-brain barrier is the major hurdle which is not allowing to cross that blood barrier into the brain. So there is no any kind of, you can say, meaning by taking some of the oral products which will crosses the BBB and they will reach to the brain to treating the disorders of the brain. There is no issue, there is no, you can say, the meaning of that particular. Then people are coming that with the new advanced technology, if you are using the nasal route, so there is a finding that if you are using nasal as a route of administration, so it will directly bypass this BBB and it will reach to the, you can say, the brain. Now see, but now if you look at again ancient days of our Ayurveda people, they were using the Nasha. Nasha, that was the concept that time they are using. And that is only thing when you are giving by the Nasha or the nasal route, it will directly reach to the brain. And that is how we can treat many of the diseases which are being there in the brain. So see, there was a nanotechnology. Only because of the tools and technology that today we have, that's why we are able to prove that. So there was a nanotechnology approach used by our people, ancient peoples and all of them. So definitely these gold nanoparticles and quantum dots that we are utilizing in the semiconductor nanocrystals, we are utilizing it for the imaging purposes as a bright fluorescence in the bioimaging and drug delivery. So many of the diagnostic devices are prepared using this nano form of materials to visualize the problems associated in the body. And one important of this discussion, that is what inorganic material. You people also heard about the silica materials, which is often from the earth, you can say, silica. And then mesoporous silica nanoparticles can be synthesized. Now people are coming with this new area of drug delivery. Just they are treating that silica, having some chemical treatment. Later on, we'll see there is one reaction I will show you. It will create nanopores over the micron size silica particle. See, basically the particle is in micron size. And on the micron size particle, we are making the nanopores, very small pores. Now see how surface area has been increased. How surface area can be increased. And now it is also helpful to load the drug into these nano confined surfaces on the micron size silica particles. Now I have done a lot of projects on this mesoporous silica nanoparticles. I have many research I published on this, and it is a greater challenge to prepare. And I think there is huge, you can say, scope for the materials to be incorporated in such a nano form, where not only we can entrap the drug at nano confined spaces, but even you can stabilize the components, you can enhance the bioavailability by increasing the surface area, you can utilize that, increase the solubility and stability even. And even if you are putting these material after drug loading, is also acting as a controlled drug delivery device that can be given by even parental route. You can give it by the parental route, but it is coated with some polymeric component which is retarding the drug to come out from these nano-confined surfaces, but being in the blood for a long time, so it will deliver the drug slowly in the chronic disorders. Otherwise, in many cases, just like in cancer diseases, we need to take the injections frequently, and that is very troublesome to the people, to the cancer patient, we can say. And you know that to improve the quality life of the cancer patients, these kind of nanoform or nanotechnology based product will the prime importance, because we know for the chemotherapy, the cancer patient, they are hesitate to take the chemotherapy because no doubt the cancer will get treated, but there is a lot of drawbacks and toxicity related issues and harm to the cancer patients due to the chemotherapy. And that's why this such a kind of nano form of technology will help us to reduce this dosing frequency even by the parental route more frequently, no need to take, and even thereby we can reduce the toxicity and unnecessary distribution to the other body region apart from the cancer region that earlier I mentioned. Now see, these are the quantum dots, just like semiconductor nanocrystal emitting the bright fluorescence used in the nano form, that is what for the bioimaging and in even drug delivery. So they will be act as this iron oxide nanoparticles we can prepare. Even this gold nanoparticles we can prepare, silver nanoparticles we can prepare, silver nanoparticle. Along with this, we can also prepare some magnetically activated drug delivery system. You know, this chemistry, I know that because we are using a part of chemistry because we are not expert in the chemistry. But nowadays we are trying to use some chemistry for synthesizing these nanoparticles. So we use the sunlight as a some sort of that we can say catalyst to synthesize the silver nanoparticles. We use biological materials just like some of the non-pathogenic bacteria to synthesize, reduce the drug into the nano-sized particle. We are using the microwave assisted drug delivery system, that is what the microwave we are using for the synthesizing the nanoparticles. Nowadays also we have one instrument that we purchased, that is monowave synthesizer. We also using that particular monowave synthesizer where rate of the reaction or the time which is required for the reaction will get reduced, and we are also getting the quality nanoparticles and small size particles even we are getting. Now, these are the different type of techniques how we are synthesizing by the green synthesis approach, we can simply say, and then we are able to prepare the nanoparticles. And they are more biocompatible, having the good quality, even from the plant sources of the material, just like Moringa oleifera, neem leaves we are using as a catalyst, and we are synthesizing, we are just making them together, the reaction, and we are converting that drug into the nanoform just by reducing reagent as a which is generated from the that leaves of the plant source. Now again come to the point how you are synthesizing this nanotechnologically developed product, but how we can utilize in a smarter way. Now, as earlier I mentioned, some of these pH sensitive, temperature sensitive, enzyme sensitive. Now see, the scientists are working continuously how smart we can make these drug delivery systems. And as I mentioned that earlier, there are various biological environments are present in the body, various biochemicals are present in the body, and then why not we can utilize those environment to activate the drug delivery system in a smarter way. And that's why the word is utilized, stimuli responsive drug delivery system. That means something external energy or internal energy is used to activate the drug delivery device which is administered into the body. And because of that activation into that area, the drug will get released. Now, one example we can discuss here, the pH sensitive drug delivery system. Now, we know the in the stomach there is acid. It is having the pH up to 1 to 2. And we know many of the drugs are sensitive to this pH. And if you have taken this drug delivery system having the sensitivity towards this acidic media, so the drug will get degraded. So in order to protect those drugs, so we can able to utilize some polymeric components where we can coat that drug delivery device, and we can say protect it from the pH environment of acidic in the stomach. Then even though there are some of the smart polymers are also there. Now suppose we want to deliver the drug in the colon region. So there is a problem which is exists in the body. Well, let us see an example of the cancer. So there is a colitis. Colitis or colon cancer is there. Suppose. Now we know that we want to deliver the drug in the colon region specifically. We don't want the drug should get released in the stomach and even in the small intestine. But now there is a challenge that you are going to take this formulation by the oral route. And if you are taking this formulation by oral route, the dosage form has to travel throughout this GI tract, that is starting from the mouth, esophagus, then stomach, and then small intestine, and then the lower part of the GI tract, that is in the colon region. Now, there is I can say, the cycle and rhythm of the body, how long that particles and materials are remaining in every part of the GI tract. So that is called as a transit time. And that's why we should have the thorough understanding of the anatomy and physiology before going to design any formulation. So if you know that the drug or any formulation or any material, that even the food material that we are taking by the oral route, they will remain for 2 to 4 hours in the stomach. That is what the transit time is. So every material needs that 2 to 4 hours. It will get breakdown in small particles, and after 2 to 4 hours, then it will go to the next region, that is what in small intestine. Then after 8 hours from small intestine, then it will go to the next region of that particular into the colon region. Now we know that the drug delivery device and drug delivery system or the dosage form you are taken, now it is traveling through this GI tract and the time span is given there. So how long time it is taking to reach to the colon region. But during this travel, the drug should not come out of the drug delivery device in the stomach, in the small intestine, and unnecessarily it will not deliver the drug. So we need to protect it. So what we are using in this case, we are using the smart polymers which are pH sensitive in nature. Now this is what the role of the polymer and chemistry is. So for example, Ultrajit are the polymers, they are the pH sensitivity. And we know that the stomach is having the pH of 1 to 2. Small intestine, it is having the pH of your 5.5 to 6 or up to 7. Then in colon region, it is having the pH of up to 8. Now we have, our chemistry people have synthesized the polymer which is pH sensitive, and that is only get eroded. That is only gets, you can say, degraded at the pH of 8. Now what we are doing then, we are coating the formulation with this polymeric material so that it will remain intact when it will travel through the GI tract till it will reach to the colon region. And as soon as it will reach to the colon region, we know that the pH is now favorable for that polymer to get degraded and eroded from the surface. And that is even in the slow fashion. The drug is also then coming out after that erosion of the surface, out of that surface. And now it is releasing the drug into the colon region only. And more specifically in the colitis, in the colon cancer, we are utilizing the more amount of the drug smartly in that particular region. So temperature sensitive, if time permits, I can use the example of this temperature sensitive material. Shall I? Hello? Hello?
Yes, sir.
Yes, sir.
Yes,
If
sir.
you are interested, I can tell some example of temperature sensitive drug
Yes, sir.
because we are using the temperature sensitive polymeric component. Just like we use that pH sensitive polymer, so definitely you can also synthesize some temperature sensitive. One example we can take in situ gelling implant or in situ gel formation of the dosage form. That is what depot preparation. I have worked on that. Many projects we carried out on this. We prepared one in situ gelling implant formulation. Now we know the implants are the special type of formulation that has been, you can say, placed under the skin by doing some minor surgery by the surgeon, and then it is again tied, and then it is kept as such for the 1 year or 2 year, whatever the time period for the delivery of the drug. And that is even in many of the disease conditions, like just like I can say the chronic diseases. Yeah, even in the contraception, like kind of that therapy. Then in case of your, we can say this chronic therapy of hypertension, then cancer and diabetes and so many other CNS disorders and maybe genetic disorders, where we need to deliver the drug for long time basis at a specific rate. And then every time to take this formulation is impossible. And even the patient which is not able to swallow this formulation is not able to take the formulation by their own, just like some of the CNS disorders, just like Alzheimer patient, Parkinson disease condition of the patient, where they are not cooperating for the taking the formulation. In such cases, we need to do such kind of approaches for the implant. Now, to do the implantation surgery, and if there is problem is exist, again you have to go back to the surgeon, you have to remove that implant in case of some emergency, and that is very difficult job. Nowadays we can prepare the injection type of preparation. Now what we can do, just like a simple injection, we are making injection, but now we are using some smart polymers in that, which are temperature sensitive. Now, what is the sensitivity of this polymer? As now at a, we can say room temperature, say not room temperature, because the temperature affecting that particular, we have to keep in the refrigerated condition of 2 to 8 degrees Celsius, and we have to just take it outside, inject the patient to the site of action. What will happen as soon as it is injected? Now it is at 2 to 8 degrees Celsius, means it is present in the water form, just watery. It looks like a simple water solution, having the drug, no doubt, but it resembles that just like it is water. Now we are injecting as an injection at the site of action. But suddenly what happened? Due to the body temperature of 37, now we have utilized one smart polymer which is sensitive to the body's temperature of 37. As soon as it will come in contact with the body temperature, after injecting, it will get convert into the gel form. Because polymer is smart polymer, and at 37 it becomes a, you can say, depot like a preparation. Now it will become a depot, means just like an implant it becomes. Now see, in this case, there is no to do the surgery. Simple as usual, you can give the injection that we are generally using that injection, but it becomes depot. And from that depot, we are also utilizing some other polymers which are retarding the drug release from that depot, and that is even in the slow fashion. And controlled and sustained delivery will be there for the long period of time. So such kind of in situ gel forming implant also we can able to prepare. Even in situ gelling eye formulation also we can prepare. Ophthalmic formulation also we can prepare. Because to prepare the ophthalmic drops, the drops are not remaining in the eyes due to its anatomy and physiology factor. A very small amount can be accumulated and it is rolled down immediately along with your lacrimal secretion, and so many other kind of factors are there which are not permitting that. But if you are preparing that in situ gel forming that implants into the ophthalmic region, we can just keep it into this fornix region of the eye and globule and this eyelid, so it can keep it as such for a long time. So the vision will also not get affected. No need to you can say instill the drops frequently in a day, 3 or 5 or 4 times a day recommended by the physician, and then it will deliver for a long time. Even in the you can talk about this many dry eye diseases. Nowadays we are using the screen time is very has been increased by everyone, the laptop and mobile phones and this social media. So dry eye diseases is the major concern with the people. So in those cases, we need to consult the physician, and they are offering then such kind of smart drug delivery system that we can put into the eye region where it will deliver that, and it will form a lubricating layer on the ophthalmic region, and thereby there is no need to utilize the drops, and simply we can have that use in the vision, proper vision. So such a smart stimuli responsive drug systems are also there. Now targeted drug delivery with the ligand functionalization. As earlier I mentioned that we can have the antibodies, we can have the peptides. I have also given the example of folic acid that we can utilize having the affinity for the cancer cell, and thereby we can target to the specific site. Now what is the, you can say, the working principle here. So by adding the ligands and functionalization, it will take that nano formulation to the site of action where that receptors are having the affinity. And that kind of materials we are going to incorporate on the nano material on the surface. We are going to functionalize it. And as soon as when it is injected or given by parental route or by any route, it will only carry to the region where it is having the affinity to the receptors in the body. Which one? The surface material that we have incorporated, functionalized, and the receptor where we need to deliver the drug. Both have the selectivity, and selectively they will get, you can say, combined, and then drug will reach to the site of action. So this is how, again, off-target drug can be avoided. Then, okay, so as it is mentioned, precision medicine, it is okay, but then futuristic medicine, but ethical considerations are very fine importance. So whatever you are doing, whatever you are synthesizing, whatever material you are using, what kind of approaches you are using, but definitely they should not create any problem to the human health, safety, and even the environment. So there should not be any effect on the while synthesizing this polymeric component, while synthesizing these nanoparticles. The environment should not get affected. So that care also we have to take. Then okay, so that this part we will skip it because there is again part of the biological process. That is for the active targeting by just ligand mediated delivery. So we will not discuss about this. So that is in depth actually, that is not needed. But many of the things under some of the cases, I think we already discussed. So that is we'll skip it. And okay, now some of the quickly I will go for this synthesis of the nanoparticles. Now this is of your interest because some of the chemistry reactions are present in the synthesizing the polymeric nanoparticles. Look at this high-speed homogenization method for the lipid nanoparticles. That means how we are making the lipid nanoparticles. So here again you can represent this presentation. This is what schematic presentation of this. So lipid plus drug solution, then high-speed sterile we are using, and then with high homogenization speed, we are converting into the drug-loaded nanoparticle. So simply, so we are using what lipids, then drug, cross polymer, and the polymers will get synthesized. That color form of the nanoparticles will, it is represented brown color, drug-loaded nanoparticles will be. So that is in slow fashion that you have to drop wise, you have to add while stirring, and you have to increase the speed, homogenize it, and the speed should be optimum, and drop wise addition should be optimum, stirring should be also optimum to get the optimized uniform size of the nanoparticle that we want to synthesize. Another method that is what schematic again, microemulsification method for the preparation of lipid nanoparticles. Here again same kind of steps are there. Some of the common steps are also there. Organic solution of and drug and lipidic materials and surfactant system that I mentioned. So it will become over type of emulsion. And then this over type of emulsion, later on you have to just evaporate the excess of the solvent, and whatever that part remaining, that is what the nanoparticles. Later you can wash these nanoparticles with the anti-solvent where it will not get solubilized again. And then you can dry it, and now these nanoparticles are ready for the design and development of nano drug delivery. One more method, that is what multiple microemulsification method. Now instead of only that's a simple traditional emulsion, that is by O by W. O by W means oil in water emulsion. W by O means water in oil type of emulsion. But now here the advanced case is there. Now it is multiple type. Maybe it is W by O by W, or otherwise O by W by O emulsion. That is why water in water, or otherwise oil in water in oil, like a preparation. So that is also, these kind of approaches also depend on the physicochemical characteristics of your drug. What is the end use of your formulation, where you are going to target, what is the environment is present there, and whether it is you are going to use for the target site of skin, otherwise oral route, otherwise parental route, or what. And it is also depend on, so what are the characteristics of the drug and even polymer. So based on that, then you can prepare these nanoparticles using this microemulsification solidification method. Now there are so many other kind of methods are there. We don't have the time to discuss more, but then synthesis, that is what for synthesizing the mesoporous silica nanoparticles. I mentioned you the silica, and now mesoporous. So meso means what? It is having some nano confined porous structure on the surface of the microparticle of your silica. And this micelle templating condensation. So these are the steps are given here. Then Stauber method, then soldier process, and template assisted method, and many more methods are there nowadays that with the help of them we can able to prepare the mesoporous silica nanoparticle, that is what MSNs. Then see, this is how one of the scheme is there for the synthesis of this MSN, that is mesoporous silica nanoparticles. So that is what it is PMA, that is polymethylic acid, and then CTAB, that is what the cetyl trimethyl ammonium bromide chemical you are using it. Then with certain conditions of the temperature, then we are just treating it. Then it converts into the one template form. Then later it is also treated with the tetraethyl autosilicate, which is then functionalized. And then calcination is very important. The calcination is nothing but very high temperature is used in this case. More than 1000 degrees Celsius temperature is used there, where it will be calcinized. And after doing the calcination, it is converted into very fine powder. But this fine powder, when you are observing under the microscope, every single particle is having the nano size or micron size. And even with the micron size, it is having the very nano size porous structure on the surface of it. And that is how then the hexagonal porous structure you can find after calcination. Then we can load the drug inside in this nanoporous confined spaces, and then thereby then you can encapsulate it. Further, you can coat it with some of the polymers if it is required. If you are using some smart delivery or into the stimuli responsive drug system, based on that you can select the polymer. Or even though if you want to delayed or control release, then also you can coat this loaded mesoporous silica nanoparticles. Now see, this is how the surface functionalization of the mesoporous silica nanoparticles, that is called as amine functionalization, thiol modification, then polymer coating, then silane coupling, and so many things. So then pegylation, then biomolecular conjugation, then fluorescent labeling, and enzyme immobilization. So all kind of things we can functionalize it, and thereby we can utilize the specific targeted drug delivery system which will be acting as a targeting to the specific site using this kind of approaches. Now, this is how another way that I mentioned earlier also, antibody functionalized and peptide functionalized, aptamer functionalized, ligand functionalized, that kind of thing. Now this is the very important interest in the AI-driven design development. And I think this AI is not, you can say, exception for you people to use in your chemistry, and everywhere it is utilized. So I think we should also not run away from this AI technology, because we generally now there are so many things we are listening and in the various reels and all kind of videos that the jobs will get, you can say, only on the basis of AI skill. So definitely, although you are working in the chemistry area, I am working in the pharmaceutical product development. But with the advanced technology, if we are not utilizing this advanced technology, then our knowledge is also wasted. For that purpose, or if you have the knowledge, definitely we need to learn about the skills of AI so that we can make a faster formulation design, and even precision is also there. Maybe quality products will also get developed, and the cost of the final formulation will also get reduced. So definitely we should use this AI technology. So AI algorithm is used to optimize the nanoparticles or nano formulations. So if you heard about that design expert or quality by design aspect, that is what QBD. So nowadays we are utilizing many of the softwares are available. With the help of that, we can able to prepare many of the, you can say, the chemistry people know very well, because for synthesizing one molecule, we need to make a plan or project or scheme for synthesizing many derivatives. And I think I heard about this chemistry screening and all kind of thing. So if you are synthesizing 1 lakh molecule, out of that 10,000 molecule will come forward, and out of 10,000 molecules, only 1,000 molecule, and thereby then 100 molecule, and from 100 molecule 10 molecules, and from 10 molecules only 1 or 2 molecules will hit in the market as a commercialized product. Now this is the journey of that synthesis of the molecules. If it is you are using that particular smart technology and softwares just to reduce the, you can say, the steps in the reactions or many of the reactions. Now you are also utilizing the same simulation techniques and molecular docking you are doing only to avoid the time which is required, and you can minimize the time, manpower, money, and as good as fast we are making that molecule available for commercialization purpose due to the competition. And because there is a huge competition in the market, so we cannot wait for them, and that's why using the smart technology in this AI design, definitely we need to use it. So many of the software design expert software is available by the Strategies USA that also we are using for the development of a formulation, just for optimizing the parameters of the reactions or optimizing the some of the parameters of our formulation, just like particle size optimization, bioadhesion property, then we can say the release rate property, that, and so many surface functionation property, and so many other kind of things are there which are associated and which need to be optimized. And definitely that's the integration of this AI technology with nanotechnology, chemistry, and pharmaceuticals. We can make a personalized nanomedicine of your scenario, today's scenario that we people need to use. Now, nanorobotics, again, self-propelled systems are there. I have many examples to tell about this nanorobotics, but time will not permit us to discuss. But definitely you will be in touch with me. I know that anyone can, if you have any question, that you can ask a question, but then in future also we'll be in touch, definitely. So we can utilize this nanorobotics. So magnetically guided drug systems are there, where we can deliver the drug, and from the outside, we can guide them to the particular site of action in the robotic form. So even though some of the nowadays remotes are also present, how that remotes can be help us to deliver selectively to the target site of the cancer treatment with the help of this already injected magnetically activated nanorobotic form of the small particles. Now nanomedicine, okay, okay. Then we need to take the approval from the definitely FDA, and these are some of the examples in this area of the nanoformulation development. That is liposomal doxorubicin, which is used in the cancer treatment, which is prepared for the chemotherapy by encapsulating the doxorubicin in liposomal form. And this nano-biomedicine reduces the toxicity and selective targeting the cancer cells, enhancing the treatment efficacy and the patient outcome. That is what quality of the life of cancer patient. Some lipid nanoparticles in preparation of the mRNA. You may heard about this during the COVID-19. The mRNA has been by Genova Biotech. They have prepared it. So these lipid nanoparticles, they are prepared by the same way as a part of this as a lipid nanoparticle form to deliver the mRNA. So that will be there. Then some of the case study of that Abraxane that is used for the pancreatic and breast cancer. Now, what is the advantage by using this nanoparticle? So Abraxane and albumin bound form of the paclitaxel. Paclitaxel is the drug actually, drug of choice for the treatment of the cancer. Now has demonstrated the remarkable efficacy in treating the pancreatic and breast cancer. So nano-biomedicine enhances the drug delivery to the site of the particular in the pancreatic region and for the topically for the breast region, and improving the patient survival rate and minimizing the side effects. So impact on the survival rate is reduced by many percentages, and now it has been passed in the many of the clinical trials, and it has been proven that so this nano form of the preparation which is used in the cancer therapy is having the great importance use in the patient. Now, even I have some of the links to read about this, but I will not show it because I will share this. Otherwise, you can read it. So they have prepared some formulation that is a smart insulin delivery. Now, insulin, you know, it is a kind of preparation, and insulin is a proteinous type of compound which is not stable in the acidic media because there is a definitely degradation and deamidation of the proteinous molecule in the by oral route, and that's why you will find that this insulin preparation is always given by subcutaneous route. Many of the patient, diabetic patient, they are taking the injections, you know, because the reason is that the insulin cannot be survive into the oral region. That's why the oral tablets are not available. You have to take the subcutaneous injections only. But now this work has made a breakthrough by preparing this formulation and as a form of nanoparticle. So insulin crystals are coated with the thin porous membrane with electrical potential sensitive channels. See how smartly it will work. Named eye crystals, and show glucose and ketone responsive insulin release. Now, this is not the smart thing that they have analyzed what is going on in the body, and then what material you can incorporate in the formulation with respect to what is going on in the body. Now, they know that the glucose is there and the ketone responsive insulin release will be there. So they are using the eye crystals which are pH sensitive and electrical potential will be there. So the owing to this high drug loading content, slow zero order insulin tiny release, eye crystal can regulate the blood glucose level for more than a month in mice when they are studied in the preclinical study with the type 1 diabetes. So this is how smartly we can work out. Now another case study is also given here in case of the CNS disorder. But let's in treating the Alzheimer and you can say Parkinson disease. Even we people also have work on this Alzheimer and Parkinson disease. We have prepared a lot more nanoparticular formulations, and we studied in preclinically in the many of the rats and rabbits, even in the mice. Then biocompatibility and toxicity concerns. So we have to keep in mind while synthesizing as a chemistry people, while synthesizing the smart and biomaterials and polymers. So there should not be any kind of toxicity. So biocompatible, biodegradable, and easy to make a surface modification, make it activate, make it functionalize, and there should not be any kind of it should show the non-immunogenic responses. So this kind of material should be synthesized. That means when you are looking at the synthesis of the molecule, and if you wish to make the use of those synthesized molecules and materials for the pharmaceutical purpose, look at these three things that we should consider. One thing, they should not show any immunological responses. Means what? Immunity should not get affected. Might be there will be hypersensitivity reactions and all kind of reactions. It should not happen with respect to the material that you have synthesized. And they should be easy to biodegrade. Once they are taken inside the body in the form of final formulation, the material should get degraded in the body only, and it will come out as a, you can say, non-toxic material from the body, as a excreted from the non-toxic material from the body. Then surface modification should be possible. So whatever material you have utilized, so because we need to make it smarter delivery system, so we need to make some surface modification. So that can be also possible. That should be possible with your whatever the material you have synthesized. So with help of that only we can able to target to the particular site in the case of the targeted drug system in treating the cancer drug. So this is also one kind of work. Somebody has worked on the lipid nanoparticles, DNA delivery for the extended. So they have greater, you can say, the findings and benefits to the patient in this case. So these are the another some examples. So okay, we'll go for this. Okay. So this is how what I mentioned, the safety concern and efficacy concern. So that is in the for human being as well as environmental. That's why we should get approval from the regulatory and ethical way, and then only we can able to make this possible to use into the healthcare sector. So this is our safety concern, accessibility, privacy, environmental impact. So this is all about the balancing. That is what risk-benefit analysis. So we need to do that. Then only we can utilize those materials for the safely into the healthcare sector. Toxicity study, biocompatibility study, that is in the early phase of your development of the synthesized component and some materials. We should go through this, and then only we can utilize for the development of the formulations or nano-biomedicine. So we need to do the in vitro studies, in vivo model study, long-term monitoring, stability studies, and then only you can take this regulatory compliance from the regulatory authorities by showing your safety and efficacy of the materials. These are the okay, fine. So this is how the market capture and all these things that is not needed at this moment to discuss. But okay, genetic disorder, fine. Futuristic medicine, okay, later we'll discuss it if time permits that one for successful nanotechnology. Okay. So this is how they have shown here how we can utilize the nanotechnology in developing the pharmaceuticals, then cosmetic preparation, agriculture, food industry. I have a lot more examples to discuss about pharmaceuticals and cosmetic preparation, but we'll see later, even agriculture product also. But then these are the examples. Okay. Okay. So what are the key takeaways from this? Targeted drug delivery can be prepared using the nanoparticle as a promising approach for the targeting in cancer treatment. Versatile application, they can utilize in the application of cancer, neurological disorder, infectious disease, and gene therapy. And in future, potentially what? So it is focused on the personalized and smart nanoparticle and customized type of medicine. Customized and personalized medicine, I will tell you in 30 seconds only. Means depending on the nature of the disease condition and depending on the nature of the body of the individual or patient. Because we are utilizing the paracetamol tablet for every individual. Example, but we don't know what is the response to the body of every individual the paracetamol is giving. Am I right? Now there are some certain categories also. Age is the group, weight is the another thing, then sensitivity of the body, then sex is the another case, that is whether male or female or like that. So there are many concerns, but the paracetamol tablet is utilized for everywhere for every patient. But we don't know what is the sensitivity of that patient, whether it is having the patient is having some previous concerns with the paracetamol sensitivity, whether the patient have some certain issues with some of the particular drug, and still we are giving that drug system. So nowadays the personalized or customized medicine is the approach where looking at the history of the body, history of the patient and individual body, we are going to develop the product by using some technology. Now 3D printing technology is also there. And then by considering that history of the patient and all kind of things, we can develop the product only for that patient. Now, actually, it is very difficult to make it large scale to the patient because in emergency cases, we cannot prepare it by considering that personality of that patient or that body of the patient and the condition of the patient. But now this is now the futuristic potential that we can work out with the smart material that we can make it possible. So these are some of the key references that I use for making this presentation, no doubt. So takeaways for the chemistry people, this is how it is. So the chemistry and nanotechnology together transferring in healthcare, how it is possible. So I'm just talking about how chemistry can work with pharmaceutical people collaboratively, and they can utilize their potential, just commercializing their molecules in the form of drug or polymeric and smart components, making the pharmaceutical products. So chemistry creates the building blocks, nanotechnology assemble them into the intelligent system, and pharmaceutical science translates them into the better therapies, and definitely the result will be the improved outcome and quality life of the patient. So as future chemist, your innovations at the molecular level can shape the medicines for the tomorrow. So the last quote is here for you people. Nothing in life is to be feared. It is to be understood. And I think by making this possible, we can run away from the fear and we can make everything possible that you think of or thought of. Thank you so much for patiently listening in me. If you have any questions and time permits, I'm here.
Sir, I have one question, sir. Hello?
Yes.
Hello?
Yes, please.
Sir, presentation, everything is very nice. I thanks for good presentation. I have one question. Practically, how possible nanorobotic use in the drug delivery, sir? Practically, suppose in the hospital, how possible?
See, actually, nanorobotics.
Nanorobotic.
Yes. I got your question. That's why I mentioned that I have little time to discuss because there are so many things that we can discuss separately as a one part. Now see, nanorobotics now being a nanoform, specifically we can utilize in the diagnostic purposes. How I can tell you? Now there are so many research has been already done. If you'll find some research now after this presentation, you just type some keywords in your Google, you will find some of the literatures where small nanorobotic form of preparations or formulations are prepared. Now they can be given by any route. More specifically, they can be given even by the parental route even. So where it will travel to the region where we can monitor from the outside on the screen even just like the surgeons are, they are doing the surgery, robotic surgery they are doing. In the same way, we have to first of all just administer that nanorobotic form of the formulation to the patient by any specific route of administration and just see what is the behavior of that particular nanorobotic form, how it is traveling, how it is going to the site of action, and that even by externally you can monitor from the device or that screen. And not only in the diagnostic purpose, but even though in delivering the medicine also it is possible to do this. And I know there are some hurdles in the development of such kind of product. Major hurdle is that a skilled personnel is required to use this. Knowledge is also required, no doubt. Then monitoring is also required. Then cost is also the factor. So if you're able to overcome those problems, definitely we can work with this nanorobotic form of the as a futuristic medicine in the diagnostic, even in the treating the many of the diseases. And they are in very small size. Even I will tell you, small magnetically activated drug system, it is in nano size or in micron size only. Now it can be injected by any route of administration of parenteral, and then you can just externally you can just travel it by just externally rotating the magnet over the surface, and even you can make it activate by the way of electromagnetic influence. Why? Because how they will get influence? Now these magnetically activated microspheres are made up of with a drug core material with a very fine magnet tiny ring inside, and that ring is not, you can say, big size, it is in very small size. Now just you can imagine micron size unit is there. Now how small magnetically activated tiny ring is there? So that is so small, and it is incorporated at the middle, surrounded by the drug core material, and the microsphere is formed, and it is coated with the polymeric component. Now once it is injected, now we have to just activate that drug system as the need of the patient is. Suppose you know that now there is a time for activating the drug delivery. Jaise ki we know that if you want to take a tablet, now suddenly we are taking the tablet. After every 4 hours, whatever the frequency of the tablet is set. So we are taking it. In the same way, now the magnetically activated system already you are administered. Only we need to activate it. So just externally you have to rotate the magnet on both the skin. What will happen? The tiny ring inside that microsphere will get activated, and at the top of that microsphere there is a non-coated portion. From that the drug will get released from at a higher rate once you are activated. And there are so many such kind of smart drug delivery systems are there that we can work out.
Thank you, sir.
Sir, nice presentation. Sir, I have a question. Sir, any result about PKPD, pharmacokinetic and pharmacodynamic results, which suggests that nanotechnology driven drug delivery is better than normal drug delivery? Any data from PKPD results?
Correct. Actually, even what I mentioned, that one example I mentioned during the discussion, nose to brain drug delivery system. Now, what I mentioned that normally if you are taking this formulation by oral route, so it will not crossing that BBB, blood-brain barrier. Okay. So there is only way either you just convert into the prodrug form. Now this is also the chemistry will work here. If the parent drug compound is not crossing the blood-brain barrier, the chemistry people can work here. They can synthesize it differently. They can just change that, you can say, molecular structural features without affecting the biological activity and compromising the toxicity. Whatever the toxicity, there should not be a toxicity. So pro-drug approach is another form of that. I can tell you the example of now dopamine in the treatment of Parkinson's. So Parkinson is nothing but there is a deficiency of dopamine into the brain. Okay. And the patients are having the less amount of dopamine release in the brain, and that's why the Parkinson's will be there. There is a CNS disorder. Now what happened? Generally, we are taking this dopamine by other route, that's what oral route. What happened? This dopamine directly will not cause the BBB. Now, instead of that, you can convert either this dopamine into the prodrug form, which is crossing the BBB. So there is an alternative as the prodrug form, that is what levodopa. That is what levodopa is the prodrug form of the dopamine. Now this levodopa as a prodrug form of the modified form of the dopamine, now it is having the tendency to cross the BBB. Now it is utilized and it will cross the BBB. So it will fulfill the requirement. Once it will cross the BBB, now it will get metabolized in the brain, and then it will convert into the dopamine. So dopamine, levodopa convert into dopamine, and the deficiency of the dopamine will get fulfilled. This is how you can work. Another approach you can do for this nose to brain delivery, instead of taking the oral route, now use the nasal cavity, and there is a direct connection of this nasal region to the brain where the BBB can be bypassed. And now we can utilize this sustain and control drug delivery device. I have a lot of research articles on this. I work on this nose to brain delivery. We have prepared a lot of preparation. We prepared very small in situ gelling formulation. We have prepared the nanoparticulate based some strips even in the nasal area, which can be adhered to the nasal region and that membrane, and for a long time, and the drug will reach to the this one brain. Now, how PKPD you talk about this? I think sir has asked the question. Mohammed sir has asked the question. Now we can isolate the brain. You can give this formulation to the nasal region, isolate the brain, and just check the availability of the drug, whether there is or not. So we can even check the amount of drug in each and every part of the brain, whether the drug has been reached to the brain or not. So that we can do. And that pharmacology people, our pharmacology people, they are doing it. So that is also skill. And we need to work it on animal, that is what rabbit, rat, and we can work on the mice. Whatever the suitable form of the. Even though we can treat many of the diseases just like a behavioral activity. If you know that a drug should get released to the brain, not quantitatively we can determine the drug inside the brain, even the behavioral activity also we can do. So in this case, there is no need to isolate the brain of the animal, but simply just check the behavioral activity. So there are some of the models in the pharmacology which are suggested scientifically. So by giving particular drug in particular condition, just like if you say the Parkinson and Alzheimer disease. So what are the conditions and symptoms of the Alzheimer and Parkinson's are there? And if you are giving the anti-Parkinson and anti-Alzheimer drug via nose to brain delivery, just after giving this drug nose to brain, just find it out how the symptoms has been changed, how the symptoms has been overcome. And then that behavioral models are also there. And that will, we can decide, we can conclude whether drug has been reached to the brain or not by just seeing the behavior of the animal, whether it has been treated or not. So that lot of things can do it.
Thank you, sir.
Sir, I have a question.
Yes, please.
Am I audible?
Yeah, you are clearly audible.
Sir, I'm just wondering that how do you determine the size of these vesicles? I mean, nanolipids.
Yes, good question. Actually, there are many tools and technologies which are available. Sophisticated instruments are available. See, one thing is that transmission electron microscopy is there, because sometimes some nanoparticles we are getting as a dispersion form. And sometimes we are unable to just isolate it from that solution. So sometimes it is possible, but just by doing the lyophilization is the one of the way by which we can able to evaporate the solvent, and we can get the free flowing powder form of the nanomaterials or nanoparticles. But sometimes it is very difficult job to remove the solvent, and that time then it is not possible to us. So in that case, what we can do, we can use that smear of that particular colloidal preparation that what we have synthesized, and then transmission electron microscope is the electron microscopy, where with the help of that we can find it out the size, even surface morphology, and related things on the surface of that particular nanoparticle. And another technology, if the particles are in the solid form, we can use the scanning electron microscopy, where the size plus surface morphology can be observed. I can tell you the example of that. I just few minutes before I talk about MSN, mesoporous silica nanoparticles. What I mentioned that even on the micron size particles, silica particles, we can able to make a nano size pores on the surface. And I will tell you, you will get surprised. 1 gram of mesoporous silica nanoparticle is having the surface area of 1 football ground area. Are you getting my point? That is 300 meter square area is there on 1 gram of mesoporous silica nanoparticle. This much. How it is possible? Only because of that micron size particle is having the nano surfaces, and if you are examining this surface with the help of some of the technology, there is a bait analysis. Bait analysis is the technology where we can able to find out the total area of the pores and surface area of the pores, and 1 gram is equal to 300 meter square surface. Such a small.
Okay. Okay, sir. Okay. Thank you, sir.
Any question again?
Yes, sir. Good evening, sir.
Good evening.
Just I want to know that whether any oral medicines in nano form are available in the market, sir.
Yes.
Since
So
we are
many
talking about it for the year.
So many preparations
Why
are
it is-
available in the market. Hello.
Yes, sir. Actually, the paracetamol we are using in a large quantity, no, sir. Why it has not come in the nano form yet?
Sir, I will tell you the example of, you can say the reason for this. Now, you know what is the dose of the paracetamol? That is dose of for average adult patient. The dose is 500 milligram, correct? And 500 milligram dose is there, and you have to take the formulation thrice or 4 times a day. So, how it will be near about more than 2 gram. And by making it nanoform again, to use some to use some of the polymeric components to convert it into the nanoform, the dose will get increased. And that's why that will become a restriction for making the tablet. Otherwise, that 2 gram tablet, 1 gram tablet will not get swallowed easily by the patient. And that is the reason why it is not available in the form of, and even the paracetamol is also not available in the sustained or controlled list formulation. The reason is the same. If you want to make the thrice a day preparation in once daily formulation, we need to accommodate 3 or 4 doses together. So dose will be higher, and that much size of the tablet cannot be swallowed by the patient. So there are certain, you can say, the hurdles in the design and development of the mean of the formulation. But no doubt, nanotechnology somehow can reduce the dose. That I can assure. So because they are in the nano size, their effectiveness, so we can reduce the dose. I'm assured about it.
Thank you, sir.
Just wait, just a minute.
Yes,
Sorry for
has
the
any questions more?
Yes.
Sir, good evening, sir.
Yes.
I'm Dr. Nedumaran from Residency College, Chennai.
Yes.
I have a doubt. There
Yes,
is a material, silicon mobile composite material, MCM41, mesoporous material, which is available. It is having 1000 square meter per gram, such a
Yes.
surface area.
Yes.
Is it possible to use the same silicon MCM for drug delivery?
Yes, sir. Definitely. Definitely, we can utilize some of the marketed formulations are also available. And personally, I can tell you because I have also prepared many formulations using the mesoporous silica nanoparticles. Many formulations. Only for the purpose how? Because to enhance the solubility, bioavailability, and stability of the drug molecule, and particularly to target to the specific region of the body. That is what the main concern of the nanotechnology is. It can be traveled to the specific site of the body, to the targeted region.
Target material, okay. But is there any possibility of affecting other normal cells by MCM41?
Yes, there is some possibility because
Some possibility.
nanomaterial always have the issues because molecularly they are reaching to the site, and at the cellular they are reaching to the site, and that's why I stress on that one point at the end even. So biocompatible material, safe material, that kind of material if you are synthesizing, there is no issue. And in case of this MSN, it is grass type of material. Grass means generally recommended as safe material. So that kind of material definitely we can utilize. Even this MSN based formulation we have prepared, I have prepared one own dealing formulation. As at the beginning I mentioned that my PhD student have received many awards at state level Avishkar and national and even international level Avishkar. So that is the base of the formulation was only the MSN, that is mesoporous silica nanoparticles, and we prepared the mesoporous silica nanoparticle glue for the wound healing purpose. So that is how we can make it possible.
Thank you, sir.
Hello, sir. Good evening. I have one question. Can you hear me, sir?
Yes.
Yeah. How these magnetic nanoparticles they help in the targeted drug delivery? And I have read the literature that the using the magnetic nanoparticles, the efficiency of the targeted drug delivery is highly increased. Can you please throw light on this?
Yeah, sir. See, I mentioned that method of preparation for the preparation of magnetically activated drug system. So as I mentioned that these kind of material, nanoparticles, they will also get come out from the body that is in unchanged form. So that what metabolic way, how it is excreted, that is also examined. And there is no issue that associated with a very small, fine magnetic ring. So they are even not visible by naked eye. Such a small size magnetic rings are utilized, and they will get excreted from the body. So there is no any issue about that magnetically activated drug system. And in market, these magnetically activated drug systems are available. Now, only thing is that the concern is that the scalability, cost is the factor. So that is what the only case is where we are not finding it in generalized way as a treatment remedy for that particular using the magnetically activated system.
Okay, sir. Thank you.
Hello, sir.
Yes.
Sir, just to shed a light on biosurfactant modified polymeric micelles for oral delivery of poorly soluble drugs.
Okay. Actually, see, the role of surfactant is to increase the surface property of the materials. For example, I can tell you some materials are hydrophobic in nature. So sometimes, and for making the drug to get dissolved completely, solubilized completely, and then after solubilization, definitely absorption will take place. So we can say the rate limiting step in the bioavailability and absorption is the only solubility of the drug compound. And see, some of the drugs have the hydrophobicity, they are hydrophobic in nature. Now we need to increase the wettability of that drug compound. Wettability, wettability. So this wettability can be possible with the help of the surface active agent and surfactants. Now the material is already hydrophobic in nature. Now we can utilize some surfactive or surface active agents, just like I can tell you the example of SLS, sodium lauryl sulfate. So it is having the HLB of 40. Then we can tell example of twin 80. So twin 80 is having the HLB of 15, which is hydrophilic. Span 80, it is having the HLB of 4. So such kind of variety of the surface active agent with their values we can choose. Otherwise, sometimes the blend